Chi è interessato, ecco, e ha la possibilità di e volesse prendere, ecco, il cibo giù, a partire su Kubernetes e sugli operatori. Quindi un grandissimo applauso per Cesare, a cui do la parola. In bocca al lupo, Cesare.
Ok, ciao a tutti. Vabbè, intanto grazie di essere qua, vista l'ampia offerta degli altri talk, molto gentili. E intanto due domande. Allora, la prima è: quanti di voi sanno almeno che cos'è Kubernetes? Bella. E quanti di voi sanno che cos'è un operatore di Kubernetes? Dai, allora ci siamo, grazie. Un'ottima audience, diciamo. Quindi, in agenda cosa abbiamo? Vabbè, molto veloce, stressando tantissimo il principio di Pareto dell'80-20, un minimo di contesto su Kubernetes, che cos'è un operatore di Kubernetes e alcuni tool, secondo me, belli, per poter in qualche modo fare development di operatori con Kubernetes. Questi tool sono Kwalk e Kpof. Sono difficili da dire, bisogna dire la verità. Allora, cos'è Kubernetes? Secondo me è un loop alla fine della fiera. Sei pazzo? Sì, diciamo che fondamentalmente c'è sempre questo controllo. Prendo lo stato corrente delle risorse dentro Kubernetes, dichiaro come operatore su Kubernetes uno stato desiderato e poi faccio il reconcile dei due stati. E questo permette tante cose, di fare tante cose. Per esempio, permette di essere dichiarativi, cioè dire quelli che sono i vostri desiderata, e ci penserà poi Kubernetes in qualche modo a fare l'alignment tra quello che è lo stato corrente e lo stato desiderato. Ma lo stato desiderato di cosa fondamentalmente? Ok, sono andato troppo avanti, e questo l'ho già detto. E quindi, ma lo stato desiderato di cosa? Lo stato desiderato delle risorse di Kubernetes. In Kubernetes tutto è un oggetto fondamentalmente persistito in un database che si chiama etcd, e le cose più piccole che in qualche modo gestisce Kubernetes sono i pods, e tutto è, tra virgolette, crudi, cioè accessibile via una CRUD API. Quindi quando si usa Kubernetes, Kubernetes fondamentalmente si usa per mettere in produzione cose. E praticamente ti dà una serie di pattern che ti permettono, che ti aiutano a mettere in produzione applicazioni containerizzate. Quali sono questi pattern? Per esempio, light availability, cioè Kubernetes è in grado di spostare pod se un nodo va giù. È possibile fare scale up con deployments replica set. È possibile fare autoscaling con l'horizontal pod autoscaling, che sono tutte risorse di Kubernetes. Altri use case sono l'health monitoring. Per esempio, i pods come risorse hanno le probe, cioè vedere se comunque la tua applicazione è responsiva, è partita con la startup probe, è in grado di, non è bloccata. Poi ci sono i servizi che in qualche modo disaccoppiano gli endpoint dai pods e fanno comunque il load balancing. Poi c'è un altro problema che c'è in produzione: esporre il tuo servizio esternamente con HTTP o HTTPS. E poi da ultimo gestire le release della tua applicazione. Anche in questo Kubernetes ti dà delle ricette già pronte, magari non bastano, però le ha. Per esempio ci sono le rolling update che ti permettono di comunque fare una nuova release senza completamente spegnere la tua applicazione. E quindi vabbè, Kubernetes che cos'è? Copre tutta una serie di use case che tu puoi avere quando devi mettere in produzione qualcosa. È soprattutto API centrico, diciamo che se in Linux tutto è un file, in Kubernetes tutto è un API di fatto, e ti permette di essere dichiarativo e non tanto non imperativo, nel senso non devi andare tu a dire a Kubernetes come gestire le tue risorse. Vabbè, la buona notizia è che comunque Kubernetes è estendibile attraverso quello che si chiamano delle custom resource definition, che sono delle risorse speciali di Kubernetes. Di fatto è un modo per pluggare una nuova API dentro Kubernetes. E anche, diciamo, il loop che abbiamo visto all'inizio, che alcuni chiamano reconciliation loop, è possibile estenderlo, quindi è possibile iniettare della logica ad hoc per le tue applicazioni. Mettiamo che tu hai un'applicazione fatta di pods che però hanno bisogno di una particolare automazione per essere gestita, puoi farlo con un operatore. Quindi, perché in qualche modo sviluppare un operatore di Kubernetes? Per esempio, io ho un deployment di un'applicazione abbastanza complesso, oppure voglio implementare un backup e recovery nella mia applicazione. Per esempio, di default c'è un etcd operator che tu puoi scaricarti per in qualche modo fare backup e recovery di etcd del tuo cluster. Hai particolari problemi di security, oppure vuoi semplicemente monitorare e fare fine tuning della tua applicazione. Bevo un attimo di acqua. Ok, ma che cos'è un operatore? Quindi, come abbiamo detto prima, è possibile in Kubernetes estendere l'API server con una custom resource definition, ed è possibile anche scrivere una logica ad hoc per questa custom resource definition. E un operatore è fondamentalmente un controller che permette di guardare queste nuove custom resource che tu puoi definire. In qualche modo è un modo di estendere il behavior di Kubernetes. Quindi questa si vede anche in fondo, magari allargo un poco. Quindi come funziona? C'è l'utente che in qualche modo fa un kubectl apply di una custom resource definition, e c'è un operatore dentro un pod fondamentalmente che controlla i cambiamenti di stato di questa custom resource definition e li comunica all'API server. La custom resource definition quindi fondamentalmente è un modo di estendere la Kubernetes API, ed è possibile creare oggetti di una custom resource definition. In questo caso un oggetto di una custom resource definition, possiamo vederlo un po' come una classe, lo vedremo dopo, è una custom resource. Quindi custom resource definition, diciamo, è il modo standard di estendere la Kubernetes API e di creare nuovi oggetti all'interno di Kubernetes. Questo qui è un esempio di custom resource definition. Non so, penso che si veda bene. Fondamentalmente cosa vediamo? Vediamo che c'è un campo kind. Il campo kind dice: questa qui fa parte del gruppo API extension, quindi lo dice il codice, stiamo estendendo l'API di Kubernetes, ed è una custom resource. In una custom resource possiamo decidere qual è lo scopo di una custom resource. Per esempio, vogliamo una custom resource che possa far parte di un namespace, vogliamo dargli dei nomi, vogliamo dargli il plurale dei nomi, oppure possiamo anche Vogliamo dare il plurale dei nomi ed è anche possibile dire quali campi fanno parte di della custom resource che noi andremo a creare dopo. E questa invece è una custom resource, cioè se prima avevamo detto che c'è la custom resource definition, oh my god, se prima avevamo detto che c'è la custom resource definition che definisce questa cof example, questo qui è la custom resource, cioè fondamentalmente stiamo in qualche modo facendo un'istanza della nostra custom resource definition, in cui in questo caso vogliamo aggiungere una label, vogliamo aggiungere alcune annotation, vogliamo dargli un nome e possiamo anche decidere di dargli dei campi. Quindi si può fare perfettamente un'analogia con quello che è l'Object Oriented Programming. Per esempio, una classe cof example, e però in Kubernetes si crea così con un kubectl apply custom resource definition.yaml. Possiamo istanziare la custom resource definition e creare una custom resource, come con kubectl apply custom resource instance. E quindi, fatto questo, che cosa abbiamo? Un operatore cosa ti dà? Ti dà degli hook che possono venire chiamati sui cambiamenti di stato di queste custom resource. Quando parliamo di eventi crude, tipo viene creata una custom resource, viene letta, viene in qualche modo aggiornata o viene cancellata. Adesso parliamo di un paio di nostri tool. Uno è KWalk, che vuole dire Kubernetes without kubelet. E fondamentalmente che cos'è? È un emulatore di Kubernetes, quindi non è qualcosa tipo Minikube o Kind, che sono dei veri cluster, di fatto hanno dei nodi, ma i nodi e i pods sono finti, c'è solo il piano di controllo. E secondo me sono ottimi, sono un laboratorio per poter costruire degli operatori, perché in qualche modo li puoi testare meglio. Facciamo finta che dobbiamo scrivere un operatore che deve gestire migliaia di pod, è difficile avere un cluster sotto mano che può gestire migliaia di pod. Con KWalk, Kubernetes without kubelet, puoi farlo, puoi simularlo. Quindi vabbè, se facciamo finta che questo qui è un mini cluster di Kubernetes in cui c'è un nodo control plane, in cui ci sono tutti i pod di Kubernetes, tipo API server, controller manager, che poi sarà quello che gestirà i nuovi operatori, e dei nodi worker, e qua in ogni nodo c'è il kubelet, che è quel demone Linux che fondamentalmente tiene in piedi tutto il cluster. KWalk è un qualcosa del genere, non c'è il kubelet. Abbiamo solo il control plane, e quindi siccome noi alla fine l'operatore lo svilupperemo nel control plane, potremo scrivere anche, volendo, dei test per scrivere il nostro operatore, che ne so, per gestire scenari di causa engineering in cui i nodi spariscono, i nodi tornano, perché non so quanti di voi hanno mai cancellato il nodo da un cluster, ma non è una cosa che si fa ogni giorno. Installare KWalk è facilissimo. Vabbè, io uso Podman perché lavoro in Red Hat, ma potete benissimo leggere Docker lì. Parte un container in cui hai un mini cluster che gira. Guarda cosa è successo. Oh my gosh. Sì. Dannata Apple. Ok, perché usare KWalk? Fondamentalmente perché è leggero, gira sul vostro laptop, non consuma CPU, non consuma memoria, ed è possibile in qualche modo emulare fino a 1000 nodi e fino a 100.000 pod. Quindi insomma potete scrivere operator complicatissimi, fondamentalmente emulando tutto. Un altro ottimo tool è Kubernetes Operator Python Framework, che è un modo facile di scrivere operatori con Python. Per esempio, troppo veloce. E dai. Per esempio, se volessimo scrivere un piccolo operatore per in qualche modo aggiungere una label quando una custom resource definition viene istanziata, quindi Coff ti dà a disposizione questa cosa abbastanza pythonica, cioè dei decoratori, cui tu puoi scrivere una funzione normalissima e digli Coff on create. Esistono vari decoratori per i vari eventi che possono succedere in una custom resource. Scrivi semplicemente sotto una funzione e gli dici, vabbè, quando una custom resource di questo tipo tu la vedi ed è in creazione, fammi una patch di questa custom resource e aggiungi una label che si chiama questa custom resource è stata operata da Coff. Per esempio, in pochissime righe di codice è possibile fare una cosa di questo genere. È meglio in qualche modo definire un kubectl che punti al tuo KWalk, è meglio definire Python unbuffered ed è possibile fare girare l'operatore dal tuo laptop. Se vogliamo mettere in produzione il vostro operatore scritto con Python, basta scrivere un Dockerfile, fare un'immagine e deployarlo con un deployment. Se volessimo scrivere un operatore nativo con Go, come facciamo? C'è l'SK Operator o KubeBuilder. Per fare un confronto, questo qua è il modo per installarsi KubeBuilder, poi bisogna dare un KubeBuilder init, bisogna fare un KubeBuilder create API e questi due tool vi costruiscono questo enorme scaffolding. Saranno 20 file in cui l'unica cosa fondamentalmente importante è questo file sorgente in cui c'è il metodo reconcile in cui voi dovete scrivere il codice del vostro controller. Ma come potete vedere quante cose in qualche modo genera. Io volevo farvi vedere questo use case che ho usato al lavoro. Cerco di farlo molto velocemente. Si tratta di Zero Touch Provisioning. Che cos'è? È una... qui non si vede bene. Immagino. Spero che si veda. Comunque, sì, adesso si vede. Comunque, vabbè, che cosa succede? È una pipeline di GitOps. Fondamentalmente GitOps vuole dire che il mio cluster non lo gestisco più io, viene gestito attraverso Git, un repository Git in cui ci sono dei documenti, quelli che sono i site config e quelli che sono i policy gen template. Site config installano clusters e i policy gen template configurano cluster dopo che sono stati installati. Argo CD guarda sempre che è il pezzo. Che cos'è Argo CD? È un operatore anche lui. Guarda continuamente il cluster che sia compliant con questi documenti e fa cose se qualcosa cambia dentro il repository Git. Poi c'è il Topology Aware Lifecycle Operator che guarda gli eventi che vengono mandati da Argo CD. E che cos'è questo Topology Aware Lifecycle Operator? È un altro operatore. Cioè, quindi come potete vedere, ogni volta che volete aggiungere dell'automazione a un cluster di Kubernetes potete usare operatori. L'Advanced Cluster Management è un altro operatore che gestisce altri cluster. Di fatto vengono installati degli agenti in questi cluster che si chiamano kubelet, che permettono di avere un control plane di tantissimi cluster. Che cosa è successo? Io al lavoro ho dovuto usare questa cosa, che è abbastanza grossina, in un caso speciale, cioè i miei cluster non erano installati tramite siteconfig, ma erano già preinstallati, però dovevo gestirli tramite questa pipeline. Cosa ho fatto? Fondamentalmente Scusate.
Il bello della diretta.
Pensavo andasse meglio. Cioè, fondamentalmente ho scritto un piccolo operatore che, siccome questi cluster vengono gestiti a seconda delle label e non venivano messe dalla parte site config, ho scritto un piccolissimo operatore in Python che in qualche modo prendesse l'evento di creazione di questi managed cluster e gli aggiungesse delle label. Quindi dove voglio andare a parare? Che alla fine della fiera ho scritto fondamentalmente lo stesso codice dell'esempio, ma ho risolto un problema, cioè sono riuscito a usare questa cosa che viene usata per installare tantissimi cluster in ambito telecomunicazioni, per poter far funzionare questa pipeline in GitOps in un modo diverso da quello con cui funzionava prima. Il modo normale era installo i cluster e poi li configuro. In questo caso venivano già preinstallati e in qualche modo configurati dopo per gestire questo use case di telecomunicazioni. E cosa ci portiamo a casa? Ci portiamo a casa che fondamentalmente K-Walk può essere utile per sperimentare casi particolari, anche casi di scala, diciamo, con tanti.
Kubernetes, ma vale lo stesso anche per OpenShift, AKS, qualsiasi distro che...
Sì, di fatto la...
Aspetta, prendi l'altro microfono. Ok, è già acceso, è già acceso.
Sì, di fatto il secondo pezzo, quello della pipeline ZTP, era OpenShift.
E in questo caso abbiamo visto che si aggiungevano delle label, l'operatore aggiungeva delle label. Quali sono le altre operazioni che possono essere fatte sul cluster utilizzando l'operator?
Beh, le operazioni vengono fatte in realtà sulle custom resource. Per esempio, nella pipeline di GitOps le custom resource che erano coinvolte erano i managed cluster, che era completamente un cluster esterno rispetto a quello che era il manager. Quindi di fatto tu puoi fare qualsiasi cosa sulle tue custom resource. Sei isolato, quindi molte volte le custom resource hanno un namespace loro, quindi non puoi fare grandissimi danni, e su queste tue custom resource puoi fare di fatto qualsiasi cosa. Per esempio, in quel grafico che avevamo visto prima, magari ci torno, se riesco. Niente, completamente andato per il cozzo. Facciamo così. No. Vabbè, in quel grafico che abbiamo visto prima, per esempio, sono coinvolte due custom resource. Uno sono i managed cluster, l'altro sono i common group update. E fondamentalmente quello che succede è che vengono presi degli eventi dall'Advanced Cluster Manager e vengono applicati automaticamente. Quello che questa parte di automatismo è aggiunta da quest'altro operatore che si chiama Topology Aware Last Second Manager. Quindi di fatto tu estendi, hai un'automazione tua che devi fare per casi particolari tipo questo è un caso particolarissimo, super di nicchia, e di fatto puoi aggiungere logica a Kubernetes e fare cose definendo le tue custom resource e operando su di queste con del codice. Quindi dal codice tu puoi fare di fatto qualsiasi cosa. Ti aggancia agli eventi. La cosa carina secondo me rispetto a Python, di Python rispetto a Go, è che ti dà questi decoratori e tu hai un decoratore per ogni evento, create, update, eccetera, eccetera. Mentre invece in Go hai soltanto l'interfaccia reconcile e da lì devi fare tutto. Oltre a costruirti quella gabbia di scaffoldi che avete visto.
Arrivo? Ultima domanda.
Mi chiedevo, ci sono differenze significative in termini di performance tra le implementazioni nei due, cioè in Go piuttosto che in Python?
Guarda, performance sono quelle di Python, in questo caso. Diciamo che secondo me in casi normali tipo questo, fondamentalmente si tratta di controllare risorse e reagire ad eventi, non ci sono grosse performance, però se te devi scrivere le tue custom resource in cui il tuo operatore deve fare qualcosa data intensive, lo scriverai in Go. Cioè la solita, la risposta è sempre dipende, ecco, siamo in questo. D'altro canto, se tu hai un piccolo use case come in questo caso e stai esplorando, devi fare un POC per questo genere di cose, è fantastico perché non devi partire, impararti CubeBuilder e come viene in qualche modo scritto un operatore in Go nativo, perché insomma non è proprio che viene facile, ecco. Mentre invece la mia esperienza è stata, io ho iniziato a scrivere questo piccolo codice, ho visto accidenti su un cluster OpenShift enorme che non ha, cioè prima ho sperimentato con KWalk, poi sono andato sul cluster vero nel mio piccolo time slot in cui potevo usarlo perché non è proprio un cluster facile da ottenere, e ho visto cavolo, ma questa cosa può funzionare, quindi io se attacco le label alla creazione del managed cluster, poi le mie policy saranno applicate e io ho risolto il mio problema fondamentalmente. E qui non c'è performance, è soltanto un reagire ad eventi e aggiungere una label. Però tu puoi fare cose tutto quello che vuoi da un operatore. Diciamo, fondamentalmente un operatore sono degli hook per estendere Kubernetes e reagisce agli eventi delle risorse di Kubernetes di fatto.
Ottimo, ottimo. E aggiungerei, siamo tutti pythonisti, quindi facciamolo in Python, no? Cesare, no? Che
Esatto.
dici? Lasciamo perdere un attimo Go. Va bene, ottimo. Ringrazio Cesare, complimenti per la presentazione.
Scusate per le
finito.
slide.
Siamo in anticipo, grazie. No, ma era il connettore. Sono andato qualche...
Okay, everybody, just hello. There we go. Just a few words before I start. Quick accessibility note. If you would like to follow along my slides on your own device, then please scan this QR code now, and you will see my slides on your phone. In particular, please do so for a couple of reasons. So one, if you have any kind of vision acuity issues and you can't really see what's being projected up here, then please snap this. If you happen to be prone to migraines and you are photosensitive, then there's a little menu button to the bottom left on your screen, and you can switch to the dark theme. So if you can't stare at a bright screen for a long time, then you can do that. Or if you want to follow along on your laptop using this URL here, then you can also hit S for speaker notes, and you will get me with subtitles. And please do that if you are, so basically you get all my speaker notes. So please do that if you're hard of hearing or if you have any other trouble following my talking. All right, so I'll put this up here for a few more seconds before we get started. I think we still have 3 minutes, right? Okay, fair enough.
Where does the exactly way comes from, the nick on Mastodon?
Oh, that's a long story.
How do you pronounce it?
You can pronounce it any which way you like.
Ti vuoi mettere tu? Io no, c'è un posto, c'era qualcuno che chiedeva, ho tenuto, però se invece... Qualcuno aveva chiesto, l'avevo tenuto. Vai. Sì, quando qualcuno aveva chiesto prima. Certo, se no.
Good morning to you all. My name is Ajifama Job. I'll be the talk manager for this session. And we have Florian Haas, who will be taking us on quite simplifying, which is to explain the concepts of complexity and drill the idea of simplification. So we will be starting right away. And if you have any questions, you can go on the platform and post it on Slido. And we will have 5 minutes for Q&A. So have a great session. Thank you.
All right, thank you for the introduction. Who is here for their first Python conference? Excellent. Okay, and who's here for your first PyCon Italia? All right, for your first, excellent. That's wonderful. Okay, so congratulations, because you've picked a wonderful community to be a part of, and you've picked an excellent conference to sort of be introduced to that community. So congratulations on that. That's wonderful. I will talk about a few projects in the course of this talk. what they have in common is that they all have a Python code base. So if we're continuing with the show of hands, who in here has heard of, has a rough idea at least of what Ansible does? Okay, plenty of Ansible people. And I mean, not necessarily being an Ansible developer or being an Ansible contributor, but just generally what it is and what it's about. Okay, Ansible. Who in here has heard of or knows a little bit about OpenEdX? Okay. Who in here has heard of a project called Tutor, also in the OpenEdX space? Python project named Tutor in the OpenEdX space. Nobody? Okay. And who in here has heard of Django? Excellent. Excellent. So that means you're in the right room, and I'm in the right room, because I have something new for all of you, and I have something familiar for all of you. Okay. Let's get started with Ansible. So this is a Python conference, so considering it's a Python project, as we've established, it's relatively safe to assume that at least a majority of people knows about Ansible, at least to some degree. And if you have ever used Ansible before, then you may have come across the Ansible GitHub repository. So the Ansible GitHub repo has Ansible's project history all the way back to February the 23rd, 2012. That's when the Ansible project started. The first commit in the Ansible GitHub repo just reads Genesis. That's all it says. And there is something up here in the repo description that I think has been there pretty much from the get-go. It has been mostly unchanged since 2012, or at least I remember it to have been there for as long as I've been using Ansible. And I got my start with Ansible relatively early on, about 2013 timeframe. Now here's what it says. I'll quote this for you. It says, Ansible is a radically simple IT automation platform that makes your applications and systems easier to deploy and maintain. Automate everything from code deployment to network configuration to cloud management in a language that approaches plain English using SSH, secure shell, with no agents to install on remote systems. Now I think of these, the second, the longer sentence, that may be a little more recent, but the first one, that's the one I think that has been there from the get-go. So it says, Ansible is a radically simple IT automation platform that makes your applications and systems easier to deploy and maintain. Radically simple. I have my doubts about that. So for those of you who are more familiar with Ansible, if you had a junior colleague, and you're an Ansible shop, say, and you had a junior colleague that's just starting out, and you're introducing them to Ansible, would you describe Ansible to that person as simple? Probably not, right? I think you wouldn't. But where does that come from? Where does that claim come from? Well, first of all, when we talk about simplicity, when we talk about whether or not something is simple, the question that you're always implicitly asking is, compared to what? And like I said, this statement has been around since 2012 when Ansible was first started. So in 2012, what you would compare Ansible to in terms of simplicity was the incumbent in its problem domain, in the server automation space, which of course at the time was Puppet, and Puppet had been around since 2005. And when you compared what Ansible could do to Puppet, Ansible was simpler at the time, largely, or at least in part, because with Ansible there was a jolly good lot of things that you couldn't do, that you could already do with Puppet. So there was simply a lot less that you could do with Ansible than you could with Puppet, and so of course Ansible looked simpler. So to summarize that bit, new systems frequently just feel simpler to you just because they can do less than established ones, specifically the ones that they're set to replace or trying to replace. And that's largely due to the fact that I'd say for about something like 90% of software systems, let's say distributed software systems, you can probably design a replacement in 6 weeks and then bang out a first release in 6 months and then spend 6 years ironing out the kinks and edge cases and corner cases. And perhaps for another 5% of software systems, the number is actually 10 rather than 6. So 10 weeks, 10 months, 10 years. But as a system grows and it adds more features and more capabilities, it's subject to a rather interesting phenomenon which really contributes to its growth in complexity. Who in here has heard of or read this article, The Configuration Complexity Clock by Mike Hadlow in 2012? Has anyone read this in this room? No. Okay. That's a real problem, I think. So what I'm going to be talking about next is from an article called The Configuration Complexity Clock, written by a guy named Mike Hadlow, who happens to be a C#.NET developer. So it's absolutely not a community that I'm a part of. He lives in the UK. He wrote this in 2012. It's one of those things that I think everybody who's in software engineering, specifically every software engineering manager, should have read, but very few actually have. In that way, it's not entirely unlike Fred Brooks's Mythical Man Month from 1975. So here's what this says. Here's what the configuration complexity clock talks about. It says to think of the sort of the development state of a system as a clock. So basically, the hands of a clock going around the clock face. So initially, we start out at noon, right? And when the system is at noon, or midnight, if you're a night owl, if you're wired that way, you start out with everything being hard-coded. So to make the system behave differently in any way, you have to change the code. That's sort of step number one. That's noon. And then, as the system evolves, we get to the point of saying, well, some ability to configure things would be really good. And we add configuration values. So those could be variables in a config file. They could be additional options or arguments for a CLI. They could be environment variables for a container. Of course, the environment variables for a container bit wasn't in the original article because nobody did that in 2012, but it's fundamentally the same approach, the same principle. So that's 3 o'clock. And then we begin to add some relationships between our config options. So it eventually becomes a rules engine. So as an example, you might be writing a CLI, you might be writing a command line interface, and that CLI has multiple subcommands. And now you're adding some kind of a mode switch that makes all or most of your subcommands behave differently based on how that mode switch is set, right? So you've effectively applied something akin to a rules engine. You're at 6 o'clock. And then all of that eventually morphs into a domain-specific language, or DSL, and we're at 9 o'clock. And then you realize that managing all that DSL by hand is too unwieldy, and you end up writing some code that generates that DSL for you. And it's noon on the configuration complexity clock again. And there's something that Mike Hadlow wrote in 2012 in that article that from today's perspective looks almost cute. So he wrote in 2012, to be honest, I've never seen an organization go all the way around the clock, but I've seen plenty that have got to 5, 6, or 7, meaning they've got about halfway around, and feel considerable pain. That's 2012. So if you look at that with the benefit of more than a decade's worth of hindsight, this is definitely an oh my sweet summer child kind of moment. Because since that article appeared, since it was published, there have been so many organizations that have taken multiple laps around the configuration complexity clock. And that includes a great many open source software projects. I've seen things that you people would not believe. And interestingly, for those of you who use Ansible kind of heavily, this is a great background for a picture, thank you. So for those of you who are using Ansible more heavily, you'll find that with Ansible specifically, there's something really interesting about it, because Ansible, it kind of embodies the configuration complexity clock, not just in terms of the development and the evolution of the project, but also about the development and the evolution of an individual Ansible user. Okay? And in that way, it's really fascinating, because if you're an Ansible novice, you start at 12 o'clock, you start at noon, you write a straight-up playbook. It's very simple. It does things, everything's hard-coded, you know exactly what it does. Then you realize it would be nice to make some values configurable. So you define some, and you perhaps add a vars file. You're at 3 o'clock. And then you create your first inventory, which aggregates hosts and adds them to groups, applies roles, sets variables to them, and suddenly you've built a crude rules engine. So now you're at 6 o'clock. And then you notice you can write your own roles, and they can have defaults, and both the roles and the defaults in those you can use like these Ginger2 expressions, and now you have this very peculiar, like really loosely defined but clearly domain-specific language, namely this weird mix in Ansible of YAML and Ginger2 and some straight-up Python sprinkled in. So you're at 9 o'clock, and then you figure out, well, hold on, I can discover most of what I need for my inventory automatically, so I don't need to maintain it manually anymore. And also you've got some Python chops, so you write a dynamic inventory driver and you're back at noon again. And then of course the cycle doesn't stop there, because now your inventory driver grows configuration options, etc., ad infinitum. So takeaway number 2, quit pretending that you can escape the configuration complexity clock. And just so I'm abundantly clear here, this is by no means limited to Ansible. The configuration complexity clock is everywhere. So if you look at other configuration platforms, say Terraform, for example, it beelines straight to a DSL. So maybe they hoped that they could sort of escape the clock that way. But then, of course, people got tired of maintaining HCL by hand, and then you got TerraGrunt. And then the Kubernetes manifests, those are another example, because people got sick of hacking those by hand and now use Helm to generate those, etc., etc. There is no escaping the clock. If you think that your next iteration will solve your complexity problem, it won't. It will just take you further around the clock, and eventually you're going to end up at noon again, and the cycle is going to start over. So just to be very clear and to illustrate the point further, let me show you examples from another project, lest you think I just cherry-picked Ansible or I'm trying to pick on Ansible or anything like that. So OpenEdX. Okay, so I can't necessarily assume that everybody's familiar with this Python project, so I'll explain a little bit about what it does. OpenEdX is a general-purpose learning platform. So if you roughly know or have used at some point the Moodle platform, right? If you've used Moodle before, and you have a rough understanding of what Moodle does, you now have a rough understanding of what OpenEdX does. It serves pretty much the same problem domain, except that where Moodle is, of course, a PHP code base, OpenEdX is a Python code base. So this project came out of a platform originally developed at MIT. There was an initial collaboration from Harvard and Stanford universities. 11 years ago, it was released as an open source project under the AGPL, the Affero GPL. So it's also been around for more than a decade. It's actually roughly the same age as Ansible, but that's pure coincidence. And it has grown sort of far beyond the academia space where it originally came from. So there's businesses using this for professional training. I use OpenEdX in my day job as somebody who writes courses on the OpenEdX platform, who helps maintain an OpenEdX platform, and I'm an occasional contributor to the project. And at its core, OpenEdX is really a Django application, or rather, it's a whole array of Django applications that all work together. So it consists, for example, it contains an LMS, a learning management system. That's what you use as a learner interacting with the platform. It has a courseware management and courseware authoring system, so that's what instructional designers and course authors use. And there's lots more adjacent components, but it's, like I said, it's basically a bunch of Django applications all working together. Now, the reason I'm mentioning it here is that OpenEdX as a project is full of great examples of how complexity, once it has been injected into a project or system, does not go away, and it does not recede either. Complexity is always here to stay. And as a corollary to that, no, you cannot make it go away by abstraction, automation, or encapsulation, because all of what they do is abstract, automate, and encapsulate. complexity. They don't make it go away. Quite the contrary. Now, before I do want to reiterate, if you like. I don't mean to pick on OpenEdX at all. Just like I didn't mean to pick on Ansible either. I do not want to insinuate that there's incompetence at work in these projects. Quite the contrary. I'm perfectly convinced that what I'm talking about applies to substantially all collaborative software development projects. If anything, I think it's probably a lot worse in proprietary ones than in open source software projects. But the fact that projects like Ansible and OpenEdX and Tutor, which I'm going to get to, and so many other projects are open source, simply enables us to look into them and investigate and analyze these things and learn from them, which is a good thing, obviously. So with that said, let me give you one of many, many illustrative examples of the permanence of complexity from this project. So early on, the OpenEdX folks decided the platform needs some kind of a shared file system. So courses in OpenEdX are essentially files. So they're imported and exported as tarballs. And then they need to be stored somewhere on the back end where all the front-end servers can access them. So this data must be accessible from multiple locations. There is an architectural requirement that follows from this that we need some kind of a shared file system somewhere on the back end. And apparently the developers at the time considered NFS to be a non-starter. They didn't want to use that. Again, we're talking 2012, 2013, that kind of time frame. They also looked at GlusterFS. They considered that. They rejected it, didn't like it. They also didn't trust CephFS. That part is totally reasonable because at the time, this was 2012, this was about 3 years before CephFS became sort of production grade. Okay, all fine. But what they eventually went with was this very strange, kind of, sort of, but not quite like a file system abstraction called GridFS, which is a MongoDB feature. And with that, they made MongoDB a core component of their platform. Now, I got my start with OpenEdX about 2015, so this would have been about 2 years after this architectural decision was made. And so about 2 years after they made this decision, they realized it was probably not a great one, architecturally. So even at that time, about 2015, the opinion among the developers was, whoops, this was a mistake. We should really get rid of MongoDB. It doesn't really make sense to have that dependency. And now we're about 10 years after that, and the project is now at the stage of, well, we'll try to get rid of it. So the project still has not managed to sort of kick that dependency. And it wasn't for lack of trying, I want to be clear about. There was an attempt to refactor all of this storage backend effectively out of the OpenEdX core, make it a separate application, which they called Block Store, another Django application which would be implemented using DRF, the Django REST framework, would interact with the front end via a REST API. It would use S3 storage or basically anything compatible, probably even anything that Django storage is supported. So you have a fairly large number of potential backends. And then they found out that that came with really bad performance. Like that kind of architecture incurred a really bad performance penalty. So they put that back into the core. And they're still not rid of their original GridFS thing. So now they've got another thing in the core and MongoDB, which of course is a burden on administrators because they need to track that for updates and manage that and whatnot, and you have no net reduction in complexity at all. Because no matter what you try, complexity does not recede. And here's another example, also from OpenEdX. OpenEdX did something that was truly great from the get-go, which was that from the beginning, they didn't just open source the platform code itself. They didn't just open source the Django applications because, number one, these Django applications all work together in a relatively complex manner but they also have other requirements. So one was the shared file system thing that I talked about, but you also need a relational database, you also need memcached, you also need a Celery backend, so Redis, for example, and so on. So if they had just thrown the platform code over the fence, it would have made the adoption of OpenEdX tremendously difficult, but they didn't do that. Instead, they also open sourced all the tooling that was required to deploy the platform in an automated fashion. And this was largely based on Ansible. At least initially, they also had officially supported CloudFormation templates, so you could get your start in AWS. You could basically bootstrap the platform in AWS, and from there on, do the rest of the configuration with Ansible. But basically, building this on Ansible playbooks meant you could effectively run OpenEdX in anything that gave you a virtual machine. You could run it in AWS, you could run it in VMware if you like, you could run it in Azure, in OpenStack, in wherever. On bare metal, if that's how you roll, fine. And that allowed you to build an architecture in an automated fashion, build and maintain an architecture in an automated fashion that looked like this. So you had an automatically deployed 3-node backend, in a highly available MySQL and MongoDB cluster that also hosted the other shared services like memcached and your Celery backend. You then had as many front-end servers as you wanted. The front-end servers were effectively stateless. So it was basically just running the stateless bits of Django. The way that you would build out and scale your platform would be you pre-installed one of these front-end VMs. You basically populated the whole thing. You took a snapshot of that, and then you deployed as many or as few as those as you'd liked. If there was an update that you wanted to include, you just refreshed that snapshot. You perhaps did so on a schedule of like once a month or twice a month if there weren't any critical updates. And scaling the front end out and in was really easy because you just spun up additional front-end servers, you plugged them in and out of a load balancer, fine, great. It was really neat and cool and useful. But of course, as it grew more features, it became more complex. And this made contributing to this set of Ansible roles and playbooks and so on a little bit challenging, particularly for new developers. So again, as with the MongoDB GridFS versus Blockstore bit, people desired simplification. And along came a project that went through a few names. Now it's called Tutor. But what that project did that emerged was enable you to run OpenEdX in Docker containers. Because, of course, containers make everything simpler, don't they? Containers simplify everything. And of course, just as with the story of Ansible and Puppet that I alluded to at the top of the talk, it was initially simpler because it could do a lot less. It was really simple to sort of spin up an OpenEdX environment with Tutor that didn't do much. But once it actually grew to a point of having feature parity, it was every bit as complex as the old stuff. And I'd say that as of today, it's also no longer significantly easier to contribute to this deployment platform than it was to the old set of Ansible roles and playbooks. So what Tutor actually does is it generates Kubernetes manifests and Docker Compose definitions for you, and it generates Docker files for you. So guess what that is? It's one more lap around the configuration complexity clock because this is code that generates a DSL for you. Or actually 3 DSLs, 2 of them YAML. But Tutor also illustrates another very classic, typical problem in complexity management, which is making complexity someone else's problem. So in Tutor, the lead author maintains a policy that the core project, will only accept new features if it benefits a large proportion of users. He doesn't say the majority, he just says a large proportion. So if you write a new Tutor feature, you write it out. You don't just suggest it. You actually write it and you send a pull request. then the author says, well, no, I'm not going to merge your pull request unless you can demonstrate that this will actually be useful to about 30 to 50% of the user base. And then, if for anything else, Tutor has a plugin system that allows you to incorporate any feature you like by writing a plugin without touching the core. Now, that sounds eminently reasonable, doesn't it? So what the author is trying to do, and I think this is a perfectly worthy cause, is he's trying to make the project no more complex than what's needed for most users. Great. But what you end up with is the core of the project being essentially unfit for purpose without plugins. So even today, we're in a situation where you cannot roll out OpenEdX without using some plugins, which are now core in all but name. And the complexity of managing all those plugins and making them work together, all of that ends up in the user's lab. So in the OpenEdX platform admin's lab in this case. And in my experience, it's not uncommon to have to run something like maybe 10 to 15 Tutor plugins to run an OpenEdX platform that can do the same as the stuff that you ran with the old Ansible playbooks. And by the way, Ansible itself has this problem too. You know, how it grew Ansible core and then collections and so on. Like we have exactly the same thing. I see people nodding who are apparently working with Ansible a lot, right? So that leads us to our next takeaway, which is that pushing downstream complexity does not reduce it. It just makes it somebody else's problem. Now, I want to be clear here. Of course, if we're the developer of something, or if we're part of the development community of something, of course, we would prefer if things were simple or simpler if given the choice. For us, the people building something as well, not just for the people using that same thing. But we do need to keep in mind that there is a ratio of upstream to downstream. There is a ratio of developers to users, and that's kind of difficult to ascertain. But, you know, like for example, if you look at Kubernetes, Kubernetes is a very large collaborative project. It has on the order of about 10,000 contributors. About 10,000 people have landed a patch in Kubernetes at some point. And now it's really difficult to estimate like how many Kubernetes clusters are out there in the world, but it's probably like single-digit millions by some estimates. So the upstream to downstream ratio, and it's also difficult to say how many Kubernetes clusters are managed by one person. It's all a bit difficult math, but we can probably assume that the upstream to downstream ratio is probably something like 1 to 1,000. So one developer for 1,000 users. If you look at curl, curl in contrast has on the order of about 1,000 committers, and it definitely has more than 1 billion users. Like if you have a smartwatch, that thing runs curl, right? If you have a car that was built in the last 10 years, that thing runs curl. Not to mention like the phone and your laptop and everything, right? So there the ratio is probably 1 to 1 million or even higher. So 1 million users for each developer. So making things simpler for some number of people while making it more difficult for orders of magnitude more people, that's not a net win. That's not a reduction in complexity either. So what can we do really to simplify, to reduce complexity? And at this point, I really hate to bust your bubble if you've been living in one, but the answer is probably nothing. And I don't say that lightly because I do have physics on my side to back me up. Okay, so bear with me for a second. We're going to go back to computers in a minute, right? But as far as we know, there are 3 fundamental physics theories that combined explain the whole universe as we know. No, they explain everything that we know about the universe, which is the whole universe. And physicists would love these to be 1, but they haven't managed that yet, so we need 3. And those 3 theories are general relativity, that explains mass and energy and space-time and gravity being one of the 4 fundamental forces of nature. Then we've got quantum mechanics with its standard model. That explains the other 3 fundamental forces of nature, namely electromagnetism and the weak force and the strong force. And that in turn explains structure and the nature of atoms and ultimately chemistry and with it biology and with it life. Helpful. And finally, we have thermodynamics, and that, among other things, explains heat and work and so on. And thermodynamics has this famous second law, the second law of thermodynamics. We can state this in various ways, but in one modern form, we say the total entropy of a system never decreases. The total entropy of a system never decreases. What does that mean? What is entropy? Entropy is the degree to which something, a system, is disorderly. And so more precisely, entropy is the number of possible configurations in a system. And of course, the more possible configurations that we have in a system, the more probable it is that the system is currently in one that isn't useful. Right? So a disorderly one. But in effect, the second law states that any system can stay just as orderly as it is now, or it can become more disorderly, but it can never again become as orderly as it once was. And the normal state of the world is that things keep getting more and more disorderly. And there's multiple standard examples of this. You can mix two paints in a bucket, but you can never unmix them. You can scramble an egg and cook it, but you can never return it to the original protein structure. And there's a curious consequence from this that kind of the physicists kind of pore over, which is that this constant growth in entropy, this constant increase of entropy, is our best explanation why time always goes forward. So, because it's a little bit weird, right? Because since Minkowski, we know that space and time are really one and the same thing. They're part of this four-dimensional thing that's called space-time. And since Einstein, we know that general relativity applies to all of that. So both space and time are influenced by mass. The principle of general relativity applies to all of those. But motion through space is reversible, whereas motion through time isn't. And that's very peculiar. It doesn't really make sense in the whole concept. Because if you have some motion through space, you can describe that with a vector. You flip the sign of that vector, boom, motion goes backwards. We don't have that option in time. We're great at time travel, but it only works forwards. And at a speed of 1 second per second. It always goes forward. And this inextricable linkage between the growth and entropy and the passage of time is really one of the best possible explanations we have for that fact, namely that time always moves forward, that we have this thing that physicists call the error of time. So reducing entropy is just as realistic as traveling backwards in time. But we can do things to speed up the growth of entropy, and then we can do the opposite to sort of slow it down. So what are ways to drive entropy in the kind of systems that we typically manage? I told you we were getting back to computers. So what drives disorder? What drives entropy in software systems? Now, of course, in principle, every addition to a software system increases entropy because whatever you can add can go wrong. Simple. But there are some things that are extremely common, and they really increase entropy much, much more, such as adding features without gating them behind a feature flag. Because if you do this, once the feature flag is rolled out, you have no way to undo it. And not only that, but any unexpected fallout from your change is not only here to stay, but it continues to accumulate, which makes the mess harder and harder to fix. Adding features without test cases means when something breaks in a later edition or in a later change, you have no idea what really broke and when. Adding features without documentation means you have no record of how the system's even supposed to behave. So you can't even tell if something broke or not. Or you can have arguments with people about it. Is this actually breakage or not? Refactoring without first achieving feature parity. You know this classic thing, oh, we're going to rewrite this bit, but this little bit of it we no longer need. So we can leave that out of the rewrite. That means you're going to run 2 or more parallel implementation strands essentially forever. Because you can be damn sure that the one thing that you thought you could leave out of the refactoring broke at least one person's workflow. And finally, violations of the principle of least astonishment, or POLAR, which means the system behaving unintuitively, that's just going to screw up everything forever. So what does that mean for the people responsible for those systems? What is their job? What is our job? if you're responsible for a system, it's your job to slow the growth of disorder in that system. And I use the term system really, really broadly here. It could be a software project, it could be a platform you manage, it could be an organizational unit you are responsible for as a manager. You will never be able to reduce disorder, and any attempt to do so pits you against a most fundamental law of physics. Because laws of physics are like terrorists, you shouldn't attempt to negotiate with them. But you can do your damnedest to slow it down. So here's what you can do. Never land a change without documentation. Always make sure that the documentation update happens simultaneously with a change. Docs define how the system is supposed to behave. Always follow the principle of least astonishment. Make sure that the system behaves in a way that intuitively makes sense. And no, following the first item in the list is not a free pass for this. Because of course, it is 100 times worse for a feature to behave counterintuitively and not be documented than to behave counterintuitively and be documented, but it's 100 times better for the system to behave intuitively and be documented. Never merge a feature without a corresponding test case. Always include the test case in the patch, in the very patch that merges the feature. Never send a new feature to prod without a feature flag. And when you decide that a particular part of the system needs refactoring, and you think there are some more things that the refactor would touch that you actually don't need anymore, what you want to do is you want to figure out what you think that you no longer need, then you deprecate that, you cut a release, you remove it, you cut another release, and then you refactor what remains. And you do so to full feature parity. And these are all things that any developer, any sysadmin, any operator can do to stem the growth of entropy in the system. But many managers are often exactly the opposite. They are entropy accelerators. They speed up the growth of disorder in the organization. So how many managers have you met that would look at a Slack channel or chat channel or whatever that their team used, and they found that communications were poor and chaotic and it was impossible to follow what was happening, and who would come up with a solution of, let's have more channels? Happens a lot, doesn't it? And that's, of course, more channels that everybody who previously followed just one channel now has to follow, and then the old channel doesn't get retired for 2 years. That's a relatively typical thing. That's not a single example. It happens all the time. And I posit that this is largely due to this weird misguided fetish that we have for this thing called leadership, because people seem to believe that in order to be useful, people must lead and do and direct others, when in reality there's at least 3 productive things that people can do when they collaborate, and one of them is not necessarily better than the others. And those 3 options are to lead, to follow, or to get out of the way. I chose to paraphrase that patent quote because it originally contained more profanity. But really, there's these 3 things that people can do in order to be productive. And people in this context very much includes managers. And I wish managers would sometimes take options 2 and 3 rather than always default to number 1 and then stirring the pot and creating ever more disorder in the process. And I want to also mention another thing that people, including but not limited to managers, very frequently misunderstand, which is there's this thing that we call the KISS principle, right? There doesn't, weirdly enough, there doesn't appear to be much consensus as to what that acronym actually expands to, because some people tend to render it as keep it simple, comma, stupid, exclamation point, as in keep it simple, you idiot. Some people like keep it simple and stupid. So like don't only try to not be complicated, but also try not to be clever. Others still render it as keep it small and simple. So, and it sidesteps the stupid bit, which is kind of polite. But for whatever reason, we seem to agree that we want to keep things simple, and then we also want to keep them either stupid or small. But however we expand this acronym, there's this one bit that's important. It is the KISS principle, not the MISS principle. It's about keeping things simple, not about making things simple. Because the principle as such is quite aptly named, and it is a good engineering principle. It reminds us that it is important to keep things simple while we can, and that is stemming the growth of entropy, slowing the growth of entropy in a system, precisely because it's impossible to make them simpler or simple later on. So that's my takeaway number 6. Aim to keep things simple because you can't make them simple. So to sum up, new is simpler than old, frequently because it can do less. You cannot escape the configuration complexity clock. Really, do make a point of reading that article. It's a good article. It's over 12 years old, but it's really good. Do read it. Complexity does not recede. Pushing complexity downstream does not reduce it. It only makes it someone else's problem. A leader's job, someone who is responsible for a system, it's their job to slow the growth of disorder in the part of the system that they're responsible for. And finally, keep things simple because you cannot make them simple. And that's my talk. Thank you very much. So we have time for a couple of questions. Do we have questions? Just one question. Okay, I'll take one question. Sorry, I can read it. So the question was, how well do you think the Python project follows the rules you laid out? I do not feel qualified to comment on that because Python is so huge and large and so many things are happening that I don't really feel qualified to speak for the Python project as a whole. But I want to say that people are actually aware of this because they are not afraid to deprecate things, take them out when they're no longer needed, when they're properly replaced, and so on. So my humble opinion is, among other projects, the Python project is doing fairly well with this. But then again, the growth of complexity is a fact, and the only thing that you can do is slow it down as much as possible while staying relevant. That's it. Okay, if anyone has any other questions, then please grab me outside. Thank you very much for your time. Enjoy the rest of the conference. Thank you.
Thank you, thank you. Can you hear me well? Excellent. All right, as you see, I have the longest title in the world. I'm not going to repeat it. She said it wonderfully. So just before we begin, just some safety instructions. As you know, we are in the pizza room. So as you've seen yesterday, please do not bring this into the room. Strictly forbidden. Italians will kill you. So just some safety instructions I was supposed to tell you. All right, so just a few words about me. As was mentioned, my name is Yossi, and I've been using Python professionally for something like 12 years now. Sounds like a lifetime. Just to give some perspective, at the time I was using Python 2.6, some of you even heard about it. And Python 3 was like the cool kid in the block. It had like parentheses for the print statement. Very exciting stuff. It's been a while. Today I work for Smitten. We are a startup from Iceland, and we are building a dating app. Yes, exactly. Very exciting. We are so excited to be a sponsor of this conference, as you can see. And yeah, very like way down below at the list of those who paid very little to become a sponsor. But that's aside. And we are obviously using Python for our backend, which is the most fun language to build the most fun dating app, of course. All right, so just before we go through what's going on, just a quick agenda. I'm going to be talking about what are operations script, which is a term that I coined, so it's definitely needs to be explained. And then we're going to go through how Python can be used to make them better, because Python is awesome. And then just go through a bunch of examples to prove my point and make me sound smart. All right, so just some definitions. What's an operation script from my point of view? So I would say an operation script is just a real script, like in the old days, that performs some kind of a routine operation. And by routine, I mean something that you write once and you use it many times, often by many people. And I gave a few examples here. It can be deploying your code from a server to a different server, or configuring a database, establishing connection to some entity, something that is kind of like annoying but has to be done. And often these problems revolve around using some kind of a third-party tool. I listed some here, like AWS or Terraform, Docker, all kinds of CLIs out there, and often it can be just using some binary that you wrote, maybe some C library that you compiled, and you just have to use it in a script. So all those things, I call them operation scripts. And naturally, since we're working with a bunch of binaries, like all these tools, the most natural thing to do is to write a bash script or a ZSH script for the Mac users of you. And yeah, or just any shell scripting language. And I like to think of them, like this is a lot of fancy words. I like to think of those scripts as the things that glues stuff together, right? You have your great business logic, your web server, your system, everything nice and fancy, tests, linters, formatters. But then there's like the last 2% of the work, which is to actually get that stuff into production. And that's where you have this little script written by someone who quit 10 years ago. Nobody knows what's happening. And like this is that, and it's just there. And it's like nobody talks about it. It's just like, yes, the magician wrote it. Don't touch it. It's just there. So like, just let's look at a few examples. So let's start with like a nice script, like a nice bash script. Here's one. I hope the code is visible. You can see this is a script. It has even the shebang line. And we're doing standard stuff like loops. We're defining a variable. And in this case, we're calling the AWS executable. It doesn't really matter what it does. We have two commands sequentially, passing some information. Not the best, not the most terrible. I think it's fine. But then, you know, this is not real life. Real life are evil scripts. And evil scripts are scripts that are like wearing a mask, right? It looks fine. It looks like just like, you know, 6 lines of happiness. But then when you look deep into what's happening, you're like, double semicolon, must be a mistake. Oh, no. It's supposed to be there. And then you're like, okay, log debug is probably a function. Where's the brackets? Or maybe there's no brackets. But wait, the if statement has double brackets. What does that mean? And you look at these things and you're like, what? Like, just what's going on? And you know, you look at the if statement and it's like strings compared to like variables, dollars, like what's happening? And you're just thinking to yourself, why can't I have a normal if statement? Like, what is going on? And at least that's my experience. And maybe everyone here is a bash professional. I find myself in this position very often. So maybe like now maybe it's a good time to make a short poll. How many of you have written or used a bash script in their life? Okay. How many of you have seen an evil script in their life? Good. That's good. Because if not, I would just go home and say like, all right. So this is good news because okay, I did the poll. So these are operation scripts, or at least how I perceive them. And in the real world, I think that they don't get the love that they deserve, right? These scripts tend to look like this, even though they are critical, right? And critical not in a sense that they are running all the time or they are like business logic, but without them, we can't do what we're supposed to do, right? We can have the best code out there. If we can't deploy it, or if we can't configure the database, or if we can't connect somewhere, it's just not there. It's just like, can you let him in? That's the, yeah, thank you, sorry. Yes, we came all the way from Iceland, didn't sleep a lot. Sorry. So yeah, so like this code is like critical, but like not in the classic sense of like it's like running in production, but it needs to work. And I have just shown you a few of the downsides of using Bash or any other scripting language, like yeah, just error handling, code inconsistency, and let's not forget the scumbag Bash that can fail and still return a success return code. Remember this guy, he's gonna come back later in the slide. Okay, so this is all nice. I've been talking shit about something else. Let's be a bit more optimistic. So a few years ago, I joined a project that was written in Erlang, a completely different programming language. It was great. We had all kinds of modern tooling, but the scripts were written in Bash. And guess who got the responsibility of maintaining all of them? Yes, Yossi, if in case you didn't notice. That was me. And I got the responsibility of maintaining all those scripts, and there were like dozens of them used by a lot of teams, and they were all in the state of like, don't touch it, it works. Like, it's just, the dollars, that's the, but also they needed to be changed. So at first I was just trying to learn Bash and understand what was going on, but I was not smart enough. So I decided to try Python, which was a language that I was just using for personal projects at the time. I decided to try out using Python for this purpose, and I set out on a quest. And my quest was to keep using the Bash for the actual raw CLI commands that I need to do, but try and do everything else in Python, because just like the most basic things, like conditions and loops, we just saw how a condition looks like. Just the most basic things are so much nicer in Python. Like the language just feels natural. Just yeah, I wrote here like strings, just like manipulating strings or handling files and all those things. And I want it to be good. Like I want a solution that is like simple to use in the sense that it just works. I don't have to think about weird things. And the code has to be maintainable, of course, unlike the Bash code. And obviously, I want to kind of leverage all the safety that Python provides. So like types, error handling, exceptions, signals, all those things. They're just so much more nice in Python. So I was going on my quest. I was trying out a few solutions in Python. There's like 3 or 4 different just built-in Python solutions. And after a few trying, I ended up with something like this. I found out there's a module called subprocess, which does pretty much what you would expect. It provides an API to run a command and interact with the output. So the result is pretty simple. We have here the run command, which just accepts a bash command or just any kind of shell command. I end up calling subprocess popen, communicate, some kind of API with some magic arguments, and I get the result back. I get the output and the error output, which are just 2 output streams of a bash command, and the return code, which we saw earlier, means nothing. It's just a number just randomly sent by a command, and good luck. So this was nice, and I wrote this pattern, and I started converting all our bash scripts at the time to use this kind of a thing. And it was very nice. I was finally able to have normal if statements and for loops and just have bash where it needs to be. And as I went, I was converting more and more scripts, and the requirements grew, and I was kind of learning what I wanted. And I figured that just using this directly was not enough. I needed something better. I wanted something super simple. I wanted you to have like just like this one function that I can call, in this case just run, and it just kind of handles all those annoying things that we do in scripts, like moving to a different directory, or setting a different environment, or piping information between 2 scripts. And I wanted to be extremely safe. I wanted something that is typed, that handles errors, handles signals, timeouts, all kinds of things that can go wrong. Because when I write my deployment script, I don't want to think about, oh, what's the return code? I just want to write the business logic that I care about, just like every other part of the code, and just let kind of someone else take care of the rest. And the subprocess module we just saw is what Python came out for this problem. But it had too many API calls. It's still too low level. It has like 4 or 5 different API calls depending on exactly what you want to do. So I figured I have to create a wrapper around it, which we did, but I wanted something fancier. So I created a Spix library. Spix was my attempt at shell Python execution. Not the best, but it's fine. It's a short word, and it was free on PyPy. So I just ended up creating this library, which is just a slightly fancier version of the same function. And this library exports the one and only function run, which looks like this. It still has just one mandatory argument, which is the string, the command that you're passing, and a bunch of configuration options that were useful for me. For example, logging the command or the output if I want to. I want automatic verification of the return code if I want to, and so on and so forth. And everything is obviously typed. And even the result, in this case an object, is a typed object that I can then Pythonically interact with. So this was my dream, like create this API that is just one function, returns one object, very simple, and kind of handles most of the boilerplate for me. And like, this comment comes at the expense of like 300 lines of code, because so many things can go wrong, like signals, errors, timeouts, output issues, all kinds of exceptions, keyboard interrupts. So this is what we have today. This is the library. It's very nice, and I'm just kind of tapping my own shoulder. But let's see it in action. So now we're going to see a few examples of real scripts from Smitten. So if you're building a dating app, you can copy that. No, you can't. It's not really interesting. The first example is going to be a very simple script where our requirements are just to kind of prepare a script for running by making sure that the AWS CLI, just some kind of binary, that it exists, that it has the right version on the system we're running. And we also want to verify that some environment variables, these two, probably some of you have seen them, that they exist. This is a classic requirement for a bash script, kind of just like verify AWS. But we're not in a bash conference, aren't we? So this is how it looks like. This is the code as it is on Smitten. You can see that we just have a function, like a Pythonic function, that does all these things, and it just does the things we said a second ago. You can see that we're running the AWS --version command, which is a bash command. You can't escape that. But all the stuff around it, checking the return code, checking the output, is done in Python. And we can do, and even though this is much more code, this is very explicit. And we can do something like starts with, which I don't even want to think about how that looks in bash. It's just, oof. Like this is very, very, very nice. Everything is obviously typed. And the second part of the environment variables, we don't even need bash for that. We can do it purely in Python, which is, in my opinion, better when possible. So this is just an example of how we take a very simple requirement for a bash script and do it in Python. All right, let's look at a slightly more complex example. So in this case, we're using the Terraform binary, which is also some kind of a CLI tool. And what we want to do is call two commands, Terraform init and then Terraform plan. And it doesn't really matter what they do, but we just want to call them one after the other. And we also want to do so in a pre-calculated or pre-provided directory and environment variable setup. So like we have some other script that does a bunch of other things, and as part, it does these two things as well. Again, looks like a classic bash script, just run the two commands and all be good. So you would think that something like this is a good start, right? We have, again, a Python function that accepts the directory and the environment variables, which are typed, and some of you have been in the type talks, and you know the types are great. So we just run the two commands, like so, and we can provide the directory and environment variables to the function, which means that we don't even have to do stuff like cd directory or preset the variable in the beginning. Like we're doing everything in Python, which is just better in my opinion. But this is a good start, and this is how we would like start with a script on Smitten. But oh no, who's back? And the script fails monster. It turns out the Terraform plan returns 0 all the time. It doesn't really care about what you're doing. It can fail, it can crash, it can timeout, it will still return 0. So that's where our utility tooling come to play. So yeah, so the Terraform plan command will always return 0, and sometimes just randomly it gives out this string error, text file busy, still returning 0, of course. And in that case, we want to retry. So we start with a simple script, but then as we test it out and we want to kind of make it more robust, we want to handle some edge cases. So we end up with something a bit more complex. We still run the Terraform plan command with a special detail exit code argument that you can find in the secret documentation that will then give you the real return code. And then we do all kinds of like result handling. Like for example, if the return code is 0 and successful, we then quit. But if it's text file busy in the output, then we like, in this case, we sleep, we could error, we could do something, and in the case of another exception, we just quit. But the nice thing is that all of this, like look how many lines of code there are here for a single bash command. And it just shows you like how many things could go wrong, and handling them in Python is just nicer, and you can add comments and all kinds of things. And obviously this increases the volume of your script by a lot, but it's safe, and it will do what you want to do, and if it doesn't, you get an indicative error, and not just like return code -1, and that's it. So this is a bit nicer, and this is how we do the actual run in our system, and this is the full script altogether. And yeah, just the important thing to see is that the bash command, each one of them has to be treated with like delicacy. Each one deserves its own block of code and has to be treated like a cat, you know, like a king. Like, you have to be super careful, because if it, like, you know, if it just moves one thing, it's just gonna crash. Okay, let's see another example. So this one is a bit of a long code. Let's see that. I hope that it works. So this is the real release script of the Smitten project. And this is just a list of things we need to do. We want to verify the AWS version. We want to clone the repository, run some script, call GitHub API, call Git API, or just in other words, a bunch of CLIs that we have to call. And what's the best place to run a few bash commands? Python. So let's see if it's bigger. Yes. So this is how the release script looks on our end. And you can see again that the first thing to notice is that each bash command is treated like gets the respect it deserves. It has its own block, and each one is handled separately because each one has a specific requirements to make it work well. And you can see that, for example, sometimes we want to like run a command and just do nothing with it, just change a directory. In another case, we want to compare the output and do some logic. Here, we want to set up a specific environment variable in the execution. This is my favorite. Here we're running a bash command, and then we're doing some magic with the output, and this is disgusting, but it's going to be even more disgusting in bash. So it's like, you know, choose your battles. And again, the important thing to see here is that we get to give the emphasis for each command, to give it like the respect it deserves, have the focus on each command separately, and we can just use Python. For example, we want to do all of this inside a temporary directory. We have the Python temp file module for that. Like, this is just pure Python. We use the AWS CLI function from before. We don't even care that it does CLI stuff behind the scenes. Like, the idea is to just migrate, at least the plan was, to migrate as much as we can of this logic into Python so that we can really have the bare commands that we need, and that just gives us safety. And now all these scripts are running in some CI machine remotely on some cloud's instance. And if they fail, I want to get an indicative error and not just return code -1 or something strange like that. So it's nice to have Python running, just like have it get a Python exception with a stack trace. And you can, of course, use stuff like breakpoints to debug it and so on and so forth. So this is all nice. And this is just how we do scripts at Smitten. And our scripts are safe. And I find this simple. I might be wrong. So just kind of thoughts about where this is going, right? So this is all very nice, and of course I am in love with the library that I wrote, but it doesn't mean that it's the best library out there, and there's quite a few alternative solutions. I mentioned some of them here, and each of these projects is essentially the same story. Some guy was trying to run Bash, and they were like, what's going on? And they just created a library, and each of them has a slightly different approach. Some of them were focusing on running stuff remotely. Some of them are looking into like just letting you import into Python commands, like all kinds of things. But everyone shared the same idea of don't use Bash directly, don't use subprocess directly. We live in a modern world, use high-level tooling. And this is what I hope for. Like, I hope that in this talk I can convince you at least a bit that there's tools out there to do those things, and the operation scripts deserve some more respect because we all have them. You know, everyone's talking about AI, AGI, and data frames, but half the internet runs on Bash scripts. Like, so it's just, I think that just using some high-level library makes them simpler to work with and more enjoyable. I think I'm enjoying doing that kind of work. But I encourage you to check out those libraries if you have those scripts, even if you don't want to admit so. And I think that would be it for me.
Thank you so much, Yossi. And we have few of the questions here, but also if you have questions, you can just raise your hand. And one of the question is it possible to pipe Cyphex command one after the other?
Is it possible to pipe? I don't know who asked this, but if you mean the pipe operator, like do for the pipe operator. So this is a great question, and I didn't prepare a slide for it, but I do have, where I have this. Sorry, I'll go back to the slide. At first, I was a bit against it, because I said if you're piping between two commands, might as well run the first command safely, make sure it succeeded, and then use the second one, because right, that's the whole idea. Because what if you pipe commands and the first one like does some random stuff, like God knows what gets piped. But sometimes you still want to do this, and I added this configuration option here, Unix raw, which just lets you pass basically like a raw bash command with pipes and what's it called, like the triangle operator and so on. It depends on the use case, and yeah, so it really depends on what you want to do. Everything should be possible, and the library, just like the script, should serve you, not you it. So yeah, it's possible, but sometimes I would not recommend it.
Thank you. And we have another question. How can these CLI functions be tested?
Great question, because I mentioned earlier that we want to have like the tests and linters and formatters. So it's a good question, and it is still a difficult part of the system to test because you are calling some third-party API. And if I think about it, we don't test that too much. We mostly rely on the library and just the safety it provides to test for the basic stuff, like that the return codes match, that there's no unexpected outputs, that nothing times out, signals out. But if you really want to test it, I would guess you would want to use some kind of a mocking. Just have a mock to the library, just like you would test any kind of third-party API. Yeah, I would say so.
Do you have any question? I can bring the mic to you. Okay.
Use this one. Hello, hello.
Hello. Hello. So I wanted to know, because there's a lot of converters now online, for example, JSON to YAML, YAML to JSON, JSON to JSON schema, etc. And what you showed us is the end result of what you had to do yourself to convert the existing bash into Python. Do you know, or is your tool providing a way to convert directly from bash to Python? To help us doing the conversion.
Do you mean if you have a bash script, like convert it to using this?
Yeah.
There is no automation. You're more than welcome to create some. Usually I would say the process for me is you start with some bash script that's already there, and you just, I usually just rewrite it or rewrite parts of it into Python. No, I don't think there's any kind of automation. I think that would be just too hard, because of all the magic that people do in bash scripts. But, AI, ChatGPT, it's really possible. Good question, thank you.
Any other questions? Okay, we have one. Okay. Yes.
I wrote a question that's there, but I might as well just ask it. If, let's say, I adopt your library and I'm starting to write scripts with Python, and I've installed your package, when would I reach out to install like a typed Python package versus calling out to a shell script? How kind of like, can you provide some guidance as to when you might install a package if you already have an environment?
Sorry, I'm trying to understand. Can you say again?
Yeah, so like at this point when the script is running, I've got the Python environment set up that has your package installed in it. Okay. When would I install some other client, for example, to call it to GitHub, versus use the CLI?
Okay. Great question. And as I mentioned, okay, I think I get it now. So many of the tools that I pointed out here, like for example, the GitHub API or AWS, they have their own Python libraries that you can use. Probably some of you use like Boto or something like that. Great question. And the answer is just like everything, it depends. I would say that when you take a bash script and convert it, it's easier to start with this because you get to keep the code as is and just kind of get like the annoying bits into Python. And most of the time, these scripts, as I said, they're not part of like the big picture. It's just like this one script, and there is some overhead to using like a library, right? It has its own quirks. So I would say it really depends. I would say start with simple. Start with like something like this, one of the libraries that do this. And if you have like a very long script or you're doing a lot of calls to the same like a third party, then I would use the CLI tool. So I would like, yeah, something like that.
Any other question? Okay, we have one online. What is the difference in Cyphax? So it is reasonable to create another library which solves the same issues.
What is the difference?
What is different in Cyphax? So it is reasonable to create another library which solves the same issues.
You mean what is the difference between this library and the others?
Yes.
Okay, I think that was the meaning. So as I said, a bunch of smart people created their own libraries to serve their own needs. And I think, again, if you're considering using one of them, you spend the 20 minutes to check out the differences. I would say each one was created to serve a different purpose. And in my case, my goal was to make stuff work. I wanted it to be safe. I wanted it to be consistent. So I was focusing on the signal handling, error handling, logging, outputs, and so on. I know the other libraries are some of them are more focused on just letting you write it faster. So you can just kind of take the bash command and just import it from Python and do something else. Some of them focus on running stuff remotely, if that's the thing you're doing mostly, if you're like deploying to Kubernetes to like a bunch of servers. So I would say, yeah, just read the docs of each of one. They're usually pretty short, and check out which one serves the needs for you mostly.
Any other question? Okay, we have one online. What does Cyphax? How does Cyphax compare with Typer? When should we use Cyphax over Typer?
Typer?
Yeah.
Good question. Typer is just for someone who doesn't know, Typer is the library created by Tiangolo from FastAPI, I think. It's yeah, I think it's more like Typer is more about how to make your Python script a CLI tool. So if I have a script that like what used to be stuff like argparse or just going to sys.argv, so Typer is more about just taking your Python code and exposing it into the shell. In this case, we're doing the opposite. We have a shell command that we want to run in Python. You could probably use both together. You could have a shell running inside a Python script, which is then exposed back to the shell. And then call yourself and just like enter in a loop of pain.
Thank you. And we have another question online. Does Cyphax define custom errors to be used in a try and except?
Yes. I probably didn't mention them, but yeah, we have, obviously, because I want to be able to handle those exceptions. And yeah, I'm not going to go deep, but basically the different types of issues that can occur during the execution, like timeout, signals, inconsistent return code, they have exceptions. Yeah, I should have probably mentioned that in the talk. We have like a top-level exception class, and it has a few ones below, and you can obviously catch that and handle that gracefully. Great question. I definitely should have mentioned that.
Any questions from the room? Okay, we have one online too.
I feel like it's just me writing to myself.
So what would be better, implementing bash commands in Python like Cyphax or use a Python API when available?
Okay, so it's just a question that was asked here before. I would say again that it really depends. And if I had to kind of like give a general solution, I would say if you have a small project, like 1, 2, 3, 5 scripts that you want to kind of convert, and that's it, then will never be anything else, don't go for the library because it has some overhead. If you have a big solution out there, then you should. But I think it really depends on the library and how good is the Python port of that library and so on. Because sometimes the Python port is just like untyped API functions, and you might as well just call the REST API. So it really depends.
Okay, so...
We have one question?
So we'll take last two and then we can...
Okay, no problem.
So, oh, you have, okay.
What's the license of your library?
Oof. I don't know. I think MIT. I just went with the GitHub default. Am I in jail? I don't know. Excellent. I think it's just the whole library is like 300 lines of code. It's not such a big thing, and yeah, MIT.
Any other question? We can take one last question. But we have one online too. Okay. Do you recommend to have many atomic scripts or a comprehensive one? The first is better to rerun in a case of errors. The latter is cleaner. How do you balance?
Those are like really questions like with a lot of responsibility. I would say just again, it depends. Depends, first of all, again, all these scripts, all these tools, it's important to remember that they are supposed to help you do your job better. If you feel comfortable, if it makes sense to have one script with a few CLI options, which we do sometimes, then have one script. If it's like completely separate two actions, one of them deploys something and the other one configures something completely different, I wouldn't use one script. I would use two separate scripts. Just like I would just look at it as the same stuff as just regular Python scripts. Just the bash part is just encapsulated. Just the same decision making you would do in deciding if to create another Python file or not. I would do the same thing here.
Thank you so much. So this is the end of the session, and I hope you guys enjoy it. It's lunchtime, right? It's lunchtime. Yeah, it's lunchtime. Sorry.
Thank you.
Prova. Hello, everyone. Thank you for coming. First, we have an announcement. The talk, Advent of Code, the panel Advent of Code, has been moved in Italia rather than Focaccia, and the talk from Focaccia was moved to Italia. Next disclaimer is to use the Slido for asking the questions, and you can upload the questions that are already asked. You can find the link on the website. So now I'll present you the speaker. His name is Nicolo. He's a passionate in data science and machine learning, and he's going to tell you a story how he built a Python bot that publishes Italian paintings on Blue Sky. Here you go.
Hello, everyone. Thank you for the introduction. And as Nicola said, basically, I'm a data scientist, but for this project of mine is a side project in which I decide to work with Italian art. And I guess since you're here, besides loving Italian food that we had for lunch, you also enjoy Italian art. So I will show you what I've done. But first, wait. It's not working, great. At least there is no demo live, so that's the worst thing that could happen. But, my gosh. It's frozen. Fantastic. Okay, so basically that's me. On one side there is my spare time, the thing I like to do in my spare time, staying with my family, my friends, my wife, Elena. And on the other side, there is the more nerdier part of me with data and programming, luckily, since I have to pay the bills. I like this stuff, and then reading books. And, well, memes, making memes is one of my passions. So after this, the idea of the project. Basically, I had this challenge that I posed for myself to make 3 side projects to learn something new in 12 months. Actually, between one of my board and the next one. And I have to tell you, a spoiler, if in the next 3 weeks I don't make other 2 projects, I'm going to fail. So it's a sure failure. But anyway, that was the idea behind the project. And I had early access to Blue Sky, that is a social network. In the next slide, I will explain a little bit about it. And I've seen a bunch of Blue Sky bots on the platform. And I said, OK, there are Blue Sky bots, so I can make it. Let's see how it is. And so that was the idea. So Blue Sky. How many of you know Blue Sky? OK, more than I thought. That's nice. Basically, for all the others, it's a microblogging social platform, and you have to think about it like Twitter, but without Elon Musk. Basically, it's something like that. So the good old Twitter. And anyway, the idea is that it's decentralized and is open source, so you can find the code on GitHub, and that's pretty cool, I would say. And the other thing is the claim, your timeline, your choice, because you can custom your feeds, even programmatically, using stuff like regex, or if you're want to go with LLMs, NLP, feel free. Maybe that's too hard for a social network, though. Anyway, so this is Blue Sky, and now I had to decide on something specific to do, because, okay, about what? So I said, why not Italian art? Because I seen one bot that was publishing a bunch of paintings. It was called something like Great Arts. But the thing was, it was by anywhere, any painting. It was such an overload of information that I thought, OK, that's a little bit crazy. And it was publishing something like 1 picture every 30 minutes. So I said, if this bot is going to have some followers, it's better to don't harass them and publish just 3 times a day. So that was the idea. And since it is a side project, I would like to keep it free for my pocket, let's say, or at least really low cost, like the cost of a beer maybe will be fine. So those are the specific idea that led to the to the work. Actually, when I outline in this way, I figured out probably already seen something like that in the past. And indeed was an article and a Twitter bot by Vicky that she doesn't need presentation. Actually, she's going to be a keynoter tomorrow, so that's great to be here in the same conference, actually. And you can see that the idea is pretty similar. Instead of socialist realism art, there is Italian art, because, well, you can hear from the Super Mario Bros. Accent where I come from. And then instead of Twitter, I'm using Blue Sky, but Python is Python. And the stack on which I deployed is not AWS. I will show you what it is, but it's pretty similar. So that's a big thanks, basically, that I have to say. So now there is the idea, but before coding, it's better to have clear the steps to do to arrive to the final goal of having this bot. So first of all, I need the images, otherwise I wouldn't publish anything. Then building the actual Python bot, and finally the deployment. So with this in mind, let's start with the collecting images part. And so the source from which I retrieved the paintings, and also Vicky did, is basically WikiArt, that you have to think about it like Wikipedia, not just because of wiki, but because it's full of paintings, statue, picture of all kind of art, from different art institutions, different nationalities of the painters, fields and genres. So it's a great place. And the really nice thing from the developer point of view is that actually it has public APIs. So for once, to make a project, you don't need to scrape the hell out of the site, but you can focus just on the content. So that was great. There was a documentation that is actually a Google Doc, because it's ever-changing. It's not really official, but it works. So with this in mind, I said, OK, for once, it's going to be a pretty easy stuff to have the paintings. So I was ready to collect the artists with this simple get request. I was able to download all the list of painters. And the artist format is this one. That's Van Gogh with his good hair, actually. And on here, you can see the format of the object that it returns for every artist. Basically, you have the artist name, the URL, that is information that we'll need for later API call. And then the other important thing is the dictionaries field. That is the last one, which these cryptic numbers that no one knows at the moment what they are. So with this in mind, I started to explore, because I was curious what those dictionaries are, because I want just Italian painters, not because I don't like other painters. Actually, Van Gogh is a great example of how good they can be, but because that was the scope of the project. So I start to say, well, tell me a famous Italian artist. And I said, Botticelli. OK. And so in Uffizi, it's full of his artwork. So if you have time, go there. And so I've looked at the information, and I've seen the dictionary numbers. So I said, OK, good information, but it's not enough to detect if here there is an information about being Italian. Then I said, another famous one, Leonardo. And something started to say, OK, maybe there is something similar in there. And then I said, another really famous one is Pinturicchio. No, this is not the right one, but sorry. And this is the correct one that I meant. It's not due to ChatGPT, it's my fault, that slide. And here, so I had all this information. And so now it's easy to see because it's red, but OK, 925 is the code for Italian artists. The funny thing was after I've done all this Sherlock Holmes work, I figured out there was an API you could call to see what was the code for Italian artists. And it was 925. So I was right. But anyway, so now it was the time to listing all the paintings and basically filtering out just the Italian artists, because I need those. And for each artist, I had a list of dictionaries of paintings. And that's the format with the board of Venus. And you have the title, the content ID, that is a unique key that will be useful for the next part of the project. And then some information like, well, the artist name and the year of completion of if it's available. spoiler, a bunch of paintings have not this information. I don't know why. And also the URL where to download the images. That will be important. Otherwise, I will be just publish information, and that would be not that nice. So with this script, piece of code, not even a script, basically I downloaded and saved the image, naming it after the content ID keys, since it was unique. And to be kind and a good person, I placed in there some time sleep to don't overrun the API. So other people could use it and not make to workload for the API. So after all the download, I was left with 18,000 images, and there were a bunch. And the thing was, from my experience in data science, in my day job, I work on image recognition system. I knew that I should look at those images because everybody thinks they are perfect, but maybe there is something wrong with those. And I was right, because indeed there were bad-looking pictures that were like, you see here the first picture, there is the image, but then there is a part of the frame, a part of the wall, so it doesn't look so on focus. There are some artwork that are different from paintings and don't render that well in the format of the social network. So even if they're cool, I had to discard them. And then there were overrepresented subjects, like in the initial JSON that I downloaded, there were like, I would say 120 artworks named The Virgin and the Child by different painters, because at that time it was, kind of trendy to paint this kind of stuff. So I decided to be ruthless on this and discard some paintings, even if they were really great, but I couldn't just publish biblical stuff all the time. So that was the idea, and from 18,000, I landed around 8,000 images. That took probably 1 minute, 2 minutes to save, but it took like 20 hours of work just going through all 18,000 of them, but it was nice. I've seen a lot of artwork, so that was not bad. And then I had to decide which one I wanted, because my idea was to have roughly something like 1,500, 2,000 images to publish in the time span of 1.5 year, 2 years. So I had to pick the one that I liked best. And okay, it was basically on personal taste, but there was also some criteria, like if there was a Mona Lisa. Any French people here? I can say it's Italian? Okay. I can say it's Italian? Yeah, okay. No, just kidding. And then no Mona Lisa and no The Bird of Venus, it wouldn't be called Italian art both. So the really famous must be kept, even because they're great, actually. Then I wanted to select some different art movements. Italy is famous particularly for these people that make great paintings back in the centuries, but there are some painters from the 20th century that make great art, so I selected by my personal taste. And then also some less known painters by the larger audience, like this painter that is a contemporary with us. So after all this selection, actually took a little less than the 20 hours the one before, I was left with 1,700 images. And so I said, okay, now it's time to write some code for the bot. So this is the architecture of Florence, but my architecture is way simpler, likely. So we have just a Postgres database, and where I dumped all the information that were collected in the JSON, because it's better to have them in a database. And then I have a monolith with the Python app and the images I'm going to retrieve to publish. And finally, on the other side of the slide, Blue Sky itself. So the database table structure, we need just a table. So we have as fields the title of the artwork, the artist name, the year of completion when available. You can see the second entry as a null value for that. The content ID that is help us to retrieve the image, since we save it by this value. And finally, the isPublish column that is a Boolean that just says to us if it already been published or not, because having to publish maybe after just some weeks, the same image wouldn't be so cool. So with that said, this is some just to give an idea of the code that you need to write a post on Blue Sky, I was really lucky because the dev team posted an article on how to do that. I post something on Blue Sky with the APIs, and it was actually written in Python, so it was a match made in heaven. And so I had just to twist for my particular use cases of publishing that kind of images. And basically the idea is that you have to make a session on Blue Sky with a token, a key, and then load the image before publishing it. So there is a two-step, loading and then publishing the image with the text that you have decided for the post, basically. Then I wrote some helper function in a file that you could call utils, but really bad, but you have to call it some way. And so in here there is a bunch of stuff like a function to format the text to have the title of the artwork, the artist, and the year of completion, if available. And then a short function to verify the token, because the endpoint I want to publish, I want to have a token. In the unlikely scenario, someone decided just to ping my endpoint and publish 1,000 images in a matter of minutes. So it will never happen, but you can never know. And finally, this on the left is all the code that you need for the app. Is a Flask app, but I just placed it there. It's probably 80 lines because the linter decided it was cool to have 80 lines instead of 40. But anyway, the important part is on the right and is divided in 3 chunks. In the first one, we are going to retrieve the painting with a select from the database. So basically, we select a random painting from the one that haven't been published yet. And then we actually make the post on Blue Sky. We first get the session to publish. Then we retrieve the image, upload it online, and format the text that we need to write for the image. And then to conclude, if everything went smoothly, and usually it does, I'm going to update the database changing the value of is published to true. So I wouldn't republish in the future the same image. So everything worked great on my laptop, but I couldn't leave my laptop on for 24/7 just for this project, so I had to deploy it on cloud. I usually at work use Azure, but it's kind of a killer solution for a project like this. So for my personal projects, I usually use Vercel because it was one of the first that I found as a solution, and it was pretty cool. Like, for instance, my blog is hosted on Vercel, and so I placed all the information in a Postgres Vercel DB, and then the monolith with the Python API written in Flask and the images. But the thing was that when I uploaded the code, there was this error, and I was like, okay, the function is too big, I have to find a solution. The function is too big because actually I was too lazy to dump the images in a blob storage and then retrieve them. I just left them there. So I thought maybe I should do that step, but then I said, no, come on, let's just try to find a solution. So I tried to reduce size, then to remove some folders around, but it didn't work. So I said, okay, but if I split I leave on Vercel the database and I put on some other service, for instance, render, that I wrote great stuff about it, it's going to work? And the answer luckily is yes. And so I published one part on Vercel and the other on render. And I was left just with one thing. I could make a post request to the API to publish the painting, but the problem is I want to automatize the kind of stuff, so the better thing is to use a cron job. Unfortunately, for my requirement to be free, both on render and Vercel cron jobs have to be paid. So I said, okay, now I have to take my credit card from the pocket, but then I said, okay, but let's Google if there is any solution, because Google still works, even ChatGPT is great now. And so I found cronjob.org that basically allows you to make probably, I will say, as many cron jobs you want. There is a limit, but I didn't need it. So that's great for me. And I made this request, scheduled 3 times a day, that published directly on Blue Sky. So the final result is here. Here you can see the Colive of St. Matthew by Caravaggio. It's a pretty nice painting. I had to select, you see, it was by something like 3 weeks ago. I had to find a really cool one that it was really known to. And there you can see live. The nice thing is the Blue Sky doesn't require registration to look at the post. Just if you want to start to work on it or publish stuff, you need to be registered, so you can take a look. And I hope it's the right QR code. It's not some crypto scam stuff. You can trust it. Otherwise, you can digit it. And anyway, what did I learn? Actually, how to build a bottom Blue Sky. There was this thing, and also use different services. I always use Vercel, but integrate also Render and CronJob was really cool. And then I think that I already knew by the many art classes that I had during my high school years, but there is a focus on specific themes based on the century. Like when the Pope or the clergy were paying for great piece of art, the themes were more focused on the Bible. In the later years are focused on other themes. And that was really cool to see through images with this project. And by the way, that's just a random icon. It doesn't not represent San Sebastiano. Do you know San Sebastiano painting with the arrows? Yeah. Okay. Anyway. So what are the next steps? Actually, it has some followers, this bot, and that was crazy. And the thing one of the users told me was, why don't you put also the name of the museum where this piece of art is exhibited, because it would be nice. So I want to integrate this thing. I've seen that it's not so easy to retrieve from WikiArt, so it will maybe need some scraping around, but that will be maybe for another talk. I don't think so, though. And then now there is the alternative text that is just the repetition of the text that we have. So for that case, it was by Caravaggio, 1600. I would like to write something more explanatory. That would be really be cooler. Maybe since I've seen so many talks about LLMs today, trying something with that would be a nice side project, let's say. And finally, promoting. Italian art doesn't need me to promote it, but you know, maybe some artists can be more known because of their great work. Okay, so thank you for your attention, and I hope you are not in this situation, but it seems like no. And those are my contacts, a bunch of them. I had to place the Blue Sky one, otherwise this talk wouldn't be here. And then if you want to check some of my blog posts, there you can find them there. I mostly talk about this kind of crazy stuff, but also some more serious thing. Thank you very much. We can share.
Thank you very much for this great talk. So there's one question on Slido. They're asking for your Blue Sky username.
There is the name of the person, because probably it's one of my colleagues that's watching streaming and he will just want to mess up probably.
Okay. So are there any more questions doing the old school way?
Actually, because I was there and I had the invite, and I had so many invite giveaway that I said, okay, well, why not to make a bot, since people don't want to come to Blue Sky and prefer Twitter probably, and that's it. And then the API was great, so I decided, you're right. Thank you. Sorry. Anyway, it's not rocket science. Just decide because it was the one available with good APIs, so that's the thing. Thank you. Thank you.
So did you have any situation where there were errors in the middle while posting, and how do you handle that?
I will answer by praying, but instead for the moment, like I had some issue at the beginning because actually render sometimes makes your serverless function sleep. So I had to handle that. But at the moment there is nothing really structured. Like there is a try except, and it just say, too bad, you are not gonna get your painting today. But that's not big of a deal. Nobody is gonna die because of that, or at least I hope. So.
So how did you do the selection at first? You mentioned for the screen out those that had bad quality and those that are not paintings but are architects, and those that has too many subject too overrepresented.
So basically, I think it was a rainy weekend, so I had not much to do. So I went through all of them, mostly. And then when I started to see the video with the child for the 20th time in a row, I said, probably that's a little too much. And then the bad quality, maybe they were not just bad quality, but it was like a detailed or a really famous painting. And it's better to see the painting itself rather than a little detail, unless it's really famous and you will like also that one. That was the selection process. But it is really biased, I'm sure about it.
Hi. I just followed your bot and I noticed some of, I even saw another person follow that bot, so it's actually at least two more. Yeah. And I noticed some of the posts are tagged as containing non-sexual nudity. Did you do that on your own, or does the bot do that, or?
So today, since it's randomly selected, I said, let's hope it doesn't select any nudity in the paintings. And indeed, it did this morning out of nowhere. So maybe next time I will prepare some posts for the talk. But anyway, the thing is, Blue Sky automatically tags it. So you can filter the kind of content you want to see. Like, okay, I'm okay with nudity, I'm not okay with nudity, and this kind of stuff. If you are not logged in, you don't see it by default. I would say rightly. I have to say maybe they are a little too Puritan on that, because some of nudity is a painting, and there are no naked people really, but even the amount of skin that is left outside is really little. So I don't know, sometimes they're extreme, but it's okay to have that by default, I would say. Thank you.
Okay, if there's no more questions, thank you. Thank you everyone for coming. I'm glad to introduce you to Siddhartha, a developer from India, and he's going to talk about the match statement and how to make your code more Pythonic and nice with using that. Go ahead.
All right, thank you. Thank you. So my name is Siddhartha. I'm from India, and I run this site, playfulpython.com, where I blog about Python topics. I'm also the author of this book, Test-Driven Python Development, which I wrote a few years back. So I've been using Python for a long time, since 2002. And one of the nice features that I like about Python is that it allows us to write really compact, nice code. Right? So a perfect example is list comprehension. Right? We can do the same thing in for loop, but we can also use list comprehension and do it in a nice way. Right? So I was very, initially when Python 3.10 came out, right? That's when they announced this match statement. So now it is 3 years. 3.10 came out 3 years back. Now 3.13 is going to come. Put your hand up. How many of you have used this feature in Python? Right? So about 1/3. And what do you all think? Do you like it or no? Okay, 1 like, 2 likes. Yeah. So this is a very controversial feature, actually. So some of the people like it. Some of the people said, you're making Python so complicated. It used to be such a simple language, and now this feature is so complicated. And people can just use if-else statement. Why do you want to use match? Right? And a lot of the objection comes from not understanding what is match. And I was also in that camp. Initially, I did not like match at all. It's like, what is this, right? And when I went to search about match statement, then you get a result like this, right? You'll learn how to use Python to create a switch case statement. Right? So switch case is there in other languages, which is like an if-else, right? And so I thought, okay. If we already have if-else, what's the big deal? Why you need to add such a feature, and everyone is saying it's so complicated, just to do if-else, right? And I didn't like it. Python is such a beautiful, simple language, and now it's becoming such a mess with these kind of features. Right? So in the beginning, I was also in that camp, like, yeah, I don't like match. Right? I still don't like that walrus, by the way. Yeah. So, but I changed my mind on match. Right? So what happened? Right? And this is the kind of example. So how many of you have never seen match? This is an example. So what you do is you say match and give the variable on top. So here direction. And you can give various cases. Right? So if direction is north, then it will execute that. It will return x, y plus 1. If the direction is south, then so it goes through all those from top to bottom. And if nothing is matching, then it will come here and run the code. Right? This is when you go to Google and all, you'll see example like this. It's like an if-else, right? And I thought, okay, I can do this if direction equal to north, if direction equal to south. I can do the same thing. Why do I need match, right? So then when I went back after some time, like many months afterwards, I went back and I saw this thing here, structural pattern matching. Right? So actually, if you look at the PEP, they don't say match is like switch case, right? They call it structural pattern matching. So I thought, okay, what is this structural pattern matching, right? And then I started investigating it some more. And then only I understood, okay, what is match, right? It's not like if-else. It's not like switch case. It's something completely different. In that example, it is similar to if-else. That's it. Right? So what I'm going to do in this talk is we'll explain a little bit about this structural pattern matching. We'll see, okay, how it works. And this is one place. Normally, Python has very good documentation. I really like it. But this feature, they really did not do a good job. If you look at the documentation for structural pattern matching, you'll see all the examples are, this is really useful if you're writing a compiler. How many of you here are writing a compiler? 1, 2. Yeah, so most of us are not writing compilers. right? Abstract syntax trees. So then what's the use of this? To put a whole feature for the compiler writers, right? But actually there are many useful scenarios which all of us can use this feature, right? But they don't explain that properly in the documentation. That's why it's missed out a lot of people. So we'll see some of those examples where we can use match in like normal programming, right? Okay, so let's think about structural pattern matching first. Okay, before that, let's just quickly do one small detour into regular expressions. So all of you know regular expressions, yeah? What is it for? What do you use it for? Matching strings, right? So you have some string, you have some pattern, right? And you want to check if that string, the characters are matching that pattern, right? And you have a language for that, like a regular expression language. So if I want to match this, I can say it's a word, and then there's an @ and a dot, starting of string. You have a syntax for it, right? So that describes the pattern. And then I can check whether the string matches that pattern. But regular expression also has another feature where I can extract parts of the pattern, right? So here I put the bracket, and then later on I can get that value. So if I run this code, it'll take just the SID part, whatever's in the matching in that bracket, and take it out. And then I can do some calculation with it. Right? So there are two concepts here. One is matching the pattern. Does the input match the pattern or not? And secondly is capturing some part of the pattern which we want. We can capture it out. Right? So these are the two important concepts in regular expression. Okay, so just remember those two. Right? So let's go to some code. Okay, here I have a code. Right? Is this all readable in the back? Yeah. Okay. So here I have a code where it's just a simulation, right? Doesn't actually do a request, but if it calls GitHub API, and if it returns a success, it returns a tuple, right here, where it returns OK, comma, and it extracts the ID field from the response. And if it's a failure, it returns another tuple, error, comma, and it returns, second one is different, right? It returns the status code. Now I'm going to call this function here, right? And now how do I process this return, right? Because when it's a success, then the second field has the ID. When it's a error, the second field has the error, right? So I need to get the value. I need to check if the first value is okay. So we have an if-then like this. What do you think about this code? Do you like it? Imagine that we can't see the get user ID. It's in some other file somewhere. I'm just reading the code. It's like this, right? It's not clear, right? What is value of 0? Is that the error, true, false? What is value of 1? We don't know, right? It's not clear. I have to go to that code and see what is it returning in this first position, second position, all that, right? Now, we can make this a little better. Okay, we can make it a little better like this. So here, in this line, instead of just taking value, I'm using Python's unpacking syntax, right? I'm getting a tuple of 2 values. This syntax will automatically put the first one in status, second one in value. So at least now we know that, okay, it's returning as a status, comma, value, right? And then it's much better. But still, in the success case, the value will have a ID. In the failure case, the value will have an error code, right? It's different, right? And that is also still not clear here, right? So if I want to really make this readable, I have to do something like this. Okay, now So you might think, what's the use of assigning the variables like this? Just for readability. Someone reads this code, at least they know what that thing is, without going to the other function, right? Now this is readable code, and Python is all about readable code, right? But now look at it. It's not so clean, right? It's kind of ugly, and it's taken so many lines to do it, right? Now let's see what we do with the match statement. Okay, here's the same code with match, right? So how does match work? Match doesn't work by matching just a value. You give it a pattern. So like regular expression, you give it a pattern. But regular expression, you give a pattern of the string. Here, you give the pattern of the structure. Okay, so here in the first match, I'm saying, here we are calling the function and getting the return value, right, in this line. And in the first case, I'm saying if the value is a tuple, okay, and the first element of the tuple is okay, it's a string, okay, and the second element can be something else. Okay, so now I'm giving a pattern. If my data is in this pattern, okay, then execute that code. So if it's a tuple, okay, comma ID, execute that code. Now what about that ID? That ID is the capture. Okay, so remember regular expressions, we can give a pattern. If it matches the pattern, we can capture part of it and use it later on. So same thing here. We give a pattern. It's a tuple. First element is okay. Second element is something else. So only two elements in the tuple. And then if it is matching that, take the second element and put it in the variable ID. Okay, that's what we are saying. And then next line we can use that variable ID. Okay, so your ID is ID. Right, so it's very simple now, right? What do you think? Do you like this one? Right? Okay, and same way for the error. Now if the first element is error, then the second one will go into the error code variable and we can use it. Right? So that's the idea of pattern matching. And why it's called structural pattern matching. It's matching the structure of the data. We're saying, oh, this is a tuple and it should have this element here and this element here. If it is matching this pattern, then do it. So like string pattern matching, you have regular expression. So structural pattern matching, you have the match case. Right? So this makes it very easy to write this kind of code where the structure can change. Right? In one case, I have a different structure. In another case, I have a different structure. Right? And then I want to do something based upon that. Then you use this. Right? Okay. So this is a simple example where we just have a tuple. Now let's look at another example. Right? Yeah. Okay, APIs. Right? Many times we work with API, and API returns back some JSON usually. One of the things about APIs is often the structure will be different. Sometimes some fields will be there, sometimes some fields will be missing. Right? Sometimes the entire structure itself will be different. So here's an example of an API. Right? This is a GraphQL API. Okay, it doesn't matter, but what matters is this is the structure of a success. So if I do the API call and it's a success, I might get a response something like this, data, and inside that something, whatever I requested. Right? But if there's an error, right, in GraphQL, it will validate everything. If there's an error, the response will be like that, JSON. So in that, there's no data, there's errors. Right? So when I do response and get the JSON, the data may be like this. I might have dictionaries and lists. Or the data may be like that with some dictionary with some other keys and some other list. Right? Now I have to process this. Now how to process this? Right? Normally, if I have to process this, I need to check, is the errors key there in my dictionary? Right? If the errors key is there, that means it's an error. So then I have to check inside the error. I have to loop, get all the messages, and process all the messages. Right? But if the error key is not there in the data, then it's a success. Right? Then I have to check, is the data key there? If the data key also is not there, something has gone wrong, right? Then I need to handle that case. Maybe the data key didn't come, right? So I need to check that. And then I might be interested in, something here, or maybe these IDs or something, right? Then I need to check, is there a hero inside that? Because any field could be missing. I might get a data, it might be an empty dictionary, right? So I cannot just directly access whatever I want. So I need to check, is there hero key? Inside the hero key, is there that hero friends, right? And inside that, so we need to check each and everything, or we need to catch exceptions, try except key error, try except index error, all those things, right? Now, if I want to process this with GraphQL, right, let's take a look. Right, so here's an example. Right, so here, we just give the pattern. Here we are giving a dictionary pattern, right? Previous example, we give a tuple pattern. Here we are giving a dict pattern. We are saying, is it a dictionary? It is having the key errors, colon. If it is matching that pattern, then whatever is the value of that key, capture it in the variable errors, right? And then I can loop for error and errors, do whatever I want to do with the errors, right? Or if it does not match that pattern, right, I can check, is it having it's a dictionary, it's having a data key, and inside that value is another dictionary having the hero friends key, then that value, capture it into the variable friends, right? And then it also allows us to add a condition. So, in list comprehension, right, we can say for this, and then in the end we can put a condition, right? If a %2 is equal to 0, right? We can give a condition at the end. So we can do the same here. So I can put a condition if none is not in friends. So if it captures all the friends, and then if any of them, all of them, none of it is none, right? Then it will succeed, it will process it. But if that condition is failed, if none not in friends, if that condition is failed, it will skip that. And it will go to the next one. So data, hero, name, capture that, and then print it. Right? So you can see how simple this code is. Right? It's 3 lines, 3 cases, each one is 2 lines. You can easily see exactly what is the pattern, what do you want to do. What's the pattern, what do you want to do. Same thing you can't do with if-else, because you have to check all the intermediate steps. Right? Any of those things may be missing, it may be none, right? Otherwise, try, except, you have to put it everywhere, right? But here, it makes it very clean, very Pythonic code, actually. Right. All right. So this thing here is called a guard. You can put it here. So let's just run this code. Okay, so this is the success scenario, right? So it ran it got the list of friends. None of it is none. So it has gone and printed each of the friends from that success response. Okay, so now I'm putting a none in the middle of the response. Okay. Okay, because I put a none, so now this case does not match anymore, right? So what it does is it captures the friends. Okay, after capturing the friends, then you can put further conditions in Python code like that on the value of that captured value. right? And it goes top to bottom. So first this failed, then it comes to this pattern. Because of that if none, not in friends, this condition also fails, right? Then it comes here, and then this condition passes, and it goes and executes that line. Right? So this is another very common example. All of us work with APIs. APIs often have like this different structures. Right? Match is really amazing for that. Okay, another example. All right. So here we see how match can be used with custom classes. So the previous one was with dictionaries. You can use with list and tuples. Here we are using match on our custom class. So I have a point data class over there. Okay, and I'm matching on the value. So I created point is 0, 10, 0. And here we can match on specific values. So if it is 0.000, we can do something. If it is 0.0, anything, 0, right? And same way for all the others. And if nothing matches, we capture all the 3 variables. So x, y, z, we capture all 3 and process it, right? So here, if we run this, yeah, so it's 10 units on the y-axis. If I make it 0, 0, 0, right, then it's on the origin. So you can also capture like this. You can extend this to even pattern match among custom classes, right? You create your own class, there's an extension. Right? And you can get more complicated. I'm not going to go into all the things what you can do with pattern matching, but just to give an idea of like how this works, right? And where you can use it. So you can say, in your case, you can say this or that, right? By using a pipe. So point of 0, x, y, like if I do something like this, yeah, so if I do like this, if it's this or that, right, then it will match. So you can give conditions like this. You can actually do very complicated. Just like regular expressions, you can do simple ones. You can also do very, very complicated regular expressions. Same way here, you can give very complicated patterns. But most of the time, you don't need to do very complicated patterns, right? Simple ones will work. Okay, so this is an example where we are working with different types of a single class, but with different values. You want to handle different values in different ways. Right, now another one. Okay, here I've got 2 different classes. So imagine you're a bookstore, right? In your bookstore, you've got books and you've got video games, right? You're like Amazon, right? So you've got books, video games. Books have got different fields and video games have got different fields. So you've got 2 different classes, one to represent books, one to represent video games, right? Now you have a shopping cart. In the shopping cart, you may be having books or video games or mixture of both. right? And you want to go through each item and process them one by one. Normally, what we would do is you have to check the class, is instance of something, something, right? You have to put a condition like that. But with pattern matching, it becomes really simple. So you can say match item and case book. So if it's a book, it will match that. And then you can capture the fields, whatever fields you want. Name, author. We can use underscore when we don't care about that field, right? So here I'm saying I want to just capture the name and author from the book. If it's a video game, then capture the name and the platform and ignore the publisher, right? So here again, we use match case. In one line, we just specify the pattern, right? And match it, capture whatever fields we want, and then process it. Right? You don't need to check if is instance. If it's book, then find book dot publisher, book dot whatever it is, name, author. Right? So here we can. So the cool thing about pattern matching is we can match the pattern and capture the pattern in one go. Right? Then there are also other examples where pattern matching just makes a simpler way of if-else. So these are all examples where in if-else it becomes very ugly code, right? But you can also use pattern matching as well, like a normal if-else, like that first example which I showed. Right? There you can use if-else, no problem, or you can use pattern matching. Personally, where I like to use pattern matching, right? A lot of people say, why not just use if-else, right? And my response is, when you take list comprehension. Right? How many of you like list comprehension? Can you raise your hand? Lots, right? Almost everyone likes list comprehension. But you can do the same thing with for loop, right? So why do you want list comprehension? Is it making the language complicated? No. It's how many of you like for loop? Raise your hand. Right? You can do that with a while loop. Right? So do you want a for loop? Right? So the thing about languages is especially when you want it to be readable. You can do everything with assembly language, right? But when you want something to be readable, it has to convey the intent, what you're trying to do, right? With a for loop, you're conveying the intent that I'm processing items one by one, right? With a while loop, I can do anything. I can go front, back, skip items, do everything, right? But with a for loop, the intent is that I'm going through a sequence one by one. And with list comprehension, the intent is I'm building a list, right? A lot of people think list comprehension is another way to write a for loop. Actually, a list comprehension is another way to write a literal list, right? Instead of giving square brackets 1, 2, 3, where I specify all the values one by one, it's a way to create a list using a formula, right? It's not a way to do a for loop. Internally, it does a for loop. Right? So same way here, where would I use match? Where would I use if statement? Right? I like to use match where I am checking for structure. Right? So if I want to check whether a list is empty, right? I can do if len of list is equal to 0. Right? That checks whether the list is empty. Or I can say match open brackets, close brackets. Okay, match case, open bracket, close bracket, also matches if it's an empty list, right? So when I'm matching structure, I like to use match statement. I don't want to say if len, you can, but this conveys the intent that I'm trying to match a structure, right? So in those cases, I think, right, match is really good. Now there are more complex cases, right? Here I've just given a few simple cases. You can make complex patterns, and I think there was a talk on functional programming also yesterday, right? In functional programming, this is used a lot, right? Because there's a lot of, in functional programming, they don't use exceptions and other things. Match gets used a lot because a lot of things are done using structure, even normal things. So those are advanced things which now you can do in Python in a very simple way. If you want to write functional programming style in Python, this is really useful. But even if you don't want to do that, right, all these use cases which I've given, any normal programming, you can just put match there. It'll make your code better. Right? Okay, cool. So let's just summarize. Okay, before we summarize, let me take one final. That example got. Okay, never mind. Here's a code. What do you think should be the output? If we give it some x, y, and direction. Any guesses? So based on the direction, it will do the calculation and return. Right? So if we look at the linter, right? You run MyPy or in your IDE, it gives this next to the code. Okay, it's giving so many errors. Firstly, it says north is not accessed. What does that mean? Right? Don't understand that error. Then it says same thing for south, east, west. And then here it says code is unreachable. Right? So something has gone wrong, but the error is not really clear. Right? So here's the important thing with match. When you have a case, whatever is inside is not a Python code. It is a pattern syntax. Okay? And in the pattern syntax, when you put a variable there, it is used for capturing a value. Okay, so when you do case north, what that means is any value, capture it into a variable called north. Right? And then I can use that variable inside. All right? And I'm not using that variable, that's why it's saying north is not accessed. All right? So this doesn't mean match it with that variable north, that string over there. It doesn't mean match it with that string over there. Right? It means, and this, there's no pattern here. So no matter what is my data, that first case will always match. And whatever is the value will be captured into a variable called north. Right? And so it can never come into any of these. That's why it gives this error, code is unreachable. Right? So we need to be a little careful here, because whatever is here is not a Python code. It's not that it's going to use that variable and match it with that. Right? It has its own syntax. That's the one thing we have to be a little careful about. Right? In fact, there's a way to get around this. We can put it into an enum or something like that. So now this is not a valid variable name, right? So it cannot be used for capture. It doesn't match the capture syntax. So now if we do it like this, the code will work as normal. So that's the only thing to remember. Whatever is here is a special syntax. It's a pattern. Just like regex has a pattern matching syntax, this also has a pattern matching syntax. Right. All right, cool. So yeah, so one final thing, right? Many times, let's go back to this code. Like this. Here we returned a tuple, right? First we returned with OK, second time we returned a different kind of tuple. Now normally in Python programming, we don't often return different structures, right? Because it's very difficult to process. When I don't know if my return value is going to be a tuple of 2 items or 3 items or 4 items. Then we have to put all those if-else check. If it has 2 items, if it has 3 items, it's complex, right? So normally what happens is we try not to return or create such a function because we cannot process it easily. Now with match statement, it becomes easy to process different structure, right? Which means it also becomes easy to write functions which return different structures. That till now we never used to do it. Now we can do it because we can easily process such functions. Right? So it also changes our behavior, how we write our original functions. Right? So that's what we have here in the final thoughts. Right? Recognize the situations where it shines and use it. You don't want to use regex to check if it is north, south, east, or west. Right? So same way, you don't need to use match for everything. Right? But As you design the system better, the match statement becomes more useful, right? So you start creating these functions which return different structures, or you start processing APIs which are in different structures. So then the match becomes really, really useful, right? Which is something we avoided till now. All right, cool. So we can take questions. How much time do we have?
Thank you very much. I will definitely start using this statement myself. So there are some questions. People are asking, Lorenzo is asking, what IDE are you using that you showed?
Oh, that's NeoVim.
Okay, thank you. And is there a benefit in performance in using the match statements versus if else?
I'm not sure about that, right? Or there is, yeah.
When it converts it to bytecode, there are less operations that are required in the match statements. Yeah.
Awesome. So it is more performant. But the main thing for me is the readability, right?
And Marco is asking, do you need a data class to pattern match a custom object, or can you avoid the data class?
You can, yeah, you can do it even with normal classes. It doesn't have to be a data class. There's a _ match _args. There's a field like that which you can use to match with any class, your own classes. Right? But it works well with data classes where you're storing different types or different structures of data. It's a good fit, but you can use it with any kind of class.
And Rodrigo is asking, you showed that Boolean operator is working. Do other operators are also working, like the ampersand and the tilde?
So OR is for matching this or that, right? It cannot match two patterns, right? This and that. So I think only OR is there, right? So it's this or this or this. And you can put that guard if those are the two options which are available.
Okay, are there any more questions live?
Yeah, thanks a lot. I was wondering about what is actually matched. You kind of mentioned right now a double under method, like double under match, which is, I guess is
rags, yeah.
Okay. So that is called when we try to match something. So I guess if we are trying to match like a complex a class with a heavy instantiation, that's probably a bad idea, right? Because
complex class which has
something that has a very heavy constructor and takes 5 minutes to create an instance of. So that's probably a bad idea because it's not we are not matching a string. We are actually matching a data. So we're building the data structure that we're matching there.
No, so that is just the pattern, right? It just tells what is the pattern. So it doesn't actually create, when we match like point of 0, 0, 0, it doesn't create a point object and match it, right? It just says that it should be a point class with the x value 0, y value 0, z value 0, right? So that is just a syntax for telling what is the pattern what we want to match.
Okay.
Okay, but that's not a Python code. It doesn't run that and create a point object and then compare the two objects. It doesn't do it that way.
Okay, and so I didn't know about double under match. So that method is a class method, I guess.
Yeah.
Okay. Okay.
So that tells you like what are the fields which need to be matched.
I see.
Right, and then in your pattern you can match those fields, whatever you specify there.
And what is the flexibility? Because, for instance, you showed an example with a two-tuple. Mm-hmm. Could we do the same if we pass to the matcher a list of 2 elements? Does it match if it's a list with 2 elements instead of a tuple of 2 elements, for instance?
No, that won't match.
So it must be the same structure.
It must be the same.
Okay, thank you.
This question, but I didn't. You asked probably this.
No, that's not me.
Okay, so we had this question online. Okay, so there's one more question. It says like this, in the first example, ID is not only a valid variable name, but also a Python inbuilt. Is it theoretically possible to match ID or the string function or others?
Yeah, so it will match. The ID will get that variable, but it's like shadowing the function name, right? So inside that block, like ID will be that variable. It's like you can, in Python, you can say ID is equal to 0. It will work, right? But then you can't use the original function. So yeah, it will work. It shadows the ID actual built-in function over there.
Any more questions live?
Yeah, good talk. In the second example, I think you showed a nested objects structure. I was wondering if you know any pattern that could match a list of objects, or we will need to traverse a list of objects and then do the matching.
So a list of objects meaning?
Yeah, like a list of dictionaries.
Okay. So like what is here?
Yeah, that's basically a nested object. So I was wondering if there is any pattern that you know, which is a list of different dictionaries. I'm just thinking of APIs.
So you can match a list if it has a fixed number, like a list containing a dictionary, comma, dictionary, comma, dictionary. You can match that way. But you cannot match list with any number. There's no pattern. Yeah. The star? Star is used for the capture, right? So if you want to capture everything into the variable, you can use the star, right? So if I give a list of star variable, it will capture the entire list into the variable.
Yeah, but maybe you can do like A, comma B, comma star tail. I don't know. To capture the first two ends.
Yeah, for the capture, you can do that, but not for matching. I think the question was, can we match the type of dictionaries, right?
Yeah, like all the objects in the
List have to be a dictionary.
Or the same.
Yeah.
Or containing, for example, hero friend.
Yeah, that way you can't.
Okay. So
Yeah.
No, that's fine.
So you want to add something, right?
Any more questions? Dan, thank you.
Cool.
That would be all. Thank you very much.
You.
And founder of Eugenics, Python-focused project and consulting company based in Germany, specializing in data finance and database space. He's going to tell us a bit more about the match statement. The stage is yours, Mark.
Thank you. So thank you for the introduction. I'm going to basically continue where Siddhartha left off. So he gave a very, very nice introduction to the match statement. I'm going to talk a bit more about advanced features that you can use and also show a lot of examples that go a lot more in depth on how you can actually parse things. So who am I? I'm Mark Limburg. I've been around for quite a while. Actually, I should probably no longer say that I've been doing Python since 1994 because that's like 30 years ago, so I'm old. So anyway, I have a consulting company. I'm doing senior architect work. I've been involved in the Python community a lot. Python Software Foundation Fellow, core developer, EuroPython Society Fellow, lots of stuff. So let's jump right in. We already heard about the match statement. This is how it looks, just to basically give you a reminder of what happened about a half an hour ago. This is the match statement as you typically write it. There are actually quite a few things in this match statement, and it's actually quite busy. If you look at the PEPs that define the match statement, there are a huge number of things that you have to know in order to understand the match statement. So everything starts out with the match object, which is up here. I don't know if this works. Let me see. No, it doesn't. So anyway, oops, sorry. So up there, the object OBG, that's the match object. That's basically what you want to match. And then you have all these patterns in here next to the case. So those are called type patterns. Well, the first ones are called type patterns. The other ones are called instance pattern. And then you can have a sequence pattern and a mapping pattern. And then you have a wildcard pattern down here. I usually basically give it a name, but you can also just use a single underscore for that. So that's basically matching everything that you can put into object. I'm just going to very briefly go over these things. So a type pattern basically matches a type. So whenever you have a list, then you go into the first case statement there. If you have an instance, then you can actually match that particular instance, and you also can look into that instance and match attributes of that instance. For sequences, you can use a list, like here. Again, you have to be careful. This is not matching a Python list. It's actually matching any Python sequence, right? So if you put a tuple here as object, then it'll match as well. And same for the mapping pattern that you have down here. It looks like a Python dictionary, but actually it's not a Python dictionary. It's basically a mapping. So any kind of mapping gets accepted for this and gets matched by this. What you can also do is you can capture values that are being matched, and you can put those into variables, as I did in the first case there, as list object. So basically whatever matches goes into the list object variable, and then you can use that in your case statement. You can also do that with things like over here. Yeah, so you can have wildcards in there. You can put data that you don't know anything in particular about. You can put that data into extra variables and then use those variables in your case statement, which is extremely powerful, and it's also a great way to do error handling. Yeah, let's say you have extra elements in your dictionary, then you can find those extra elements by looking into those variables. And then, of course, finally, you have the guards. So basically, you can put extra conditions there. So if this matches, you're not entering the case just yet. But instead, what happens is you put all the variables in here into ABC, and then you can have a condition here, which is then applied to that particular case. And you only go into the case statement if that condition matches. So that's also a very, very powerful thing to have and to use. Now, why am I giving these talks? I have another talk on the match statement as well, a simple one, which is kind of similar to what Siddhartha did. I basically decided to do this because I found that the match statement is not being used a lot. And the reason behind that is I tried in 2001 with PEP 275 to get a switch statement, which is kind of similar, into Python, and it was rejected at the time. So I was lucky, 20 years later, we finally had something similar in Python. And of course, I wanted to succeed because I think it's actually very, very useful. And the match statement is a lot more powerful than what I had in mind back then, because basically I just wanted to get the C kind of switch statement into Python. Match can do a lot more, and I'm going to show a few of those cases. Now, there is a project here for PyPI, which is called, it's a bit small here, it's pi-code.org. You can get a lot of data about packages on PyPI. And the author of that website also did an analysis of language features used by those packages. So you can actually go in and find out which of these language features are being used by the Python community. And it turns out that in July last year, there were only about 0.5% of all packages on PyPI using the match statement. And given that it's been around for 3 years, at the time of those statistics, it was about almost 2 years. So it's not really used a lot. And every time I do a poll about these things, you don't see a lot of hands go up. So I think we need to have more of these talks. One of the reasons for this, I guess, is documentation. Because if you want someone to use whatever you put into the language, of course you need good documentation for that. Unfortunately, we only have these PEPs. And the PEPs are really very, very technical. The best way to start is PEP 636 if you want to learn about the syntax. The other ones are more about how everything works internally. And if you want to get into the true details, then that is something that you should read. But otherwise, they're not very helpful. And the Python documentation on these things is not very helpful either, because it doesn't give more context than those PEPs. So it would be nice to get a bit more information, a bit more documentation about these things, and maybe a few tutorials as well. If you go on the net and you try to figure out what the match statement is all about, you get lots and lots of examples, but only very basic ones. So some of the things that Siddhartha talked about, you can see on this slide as well, but these are actually features that get used in advanced parsing. So, for example, it is possible to use an OR pattern. So you can use OR matching, and you can have multiple values that match, for example, in the first case there. Another one is that you can do wildcard matching. So you can put values in here that you don't really want to know about. You just want to know, for example, in the second case there, that you want to have a 1 and a 4 in the last entry. You can do instance parsing, which is extremely helpful. Element is from elementary in this case. I'm going to show an example using that as well. So you can actually match on attributes and even go nested, right? I tried to show this in here a bit, because you can use all these different patterns that you have, and you can nest them arbitrarily. So you can be as complex as you want, if you want. You can also put local variables in there. What Siddhartha already mentioned is that anything that looks like a variable, like for example type name in here, is going to be a capturing variable. So whatever the match statement logic matches goes into this variable and gets assigned to the variable. If you want to use a variable that's already defined before your match statement, then you have to put a dot in here. And the dot basically then says to the match statement, okay, this is going to be something that I have to look up in the local namespace. And then you use the value that gets looked up like that. So it's very easy to just put these things into enums, for example, or just have them in classes and then use a dot to access those. There are a few more tricks that you can use. You can have a look at Raymond Hettinger's talk from 2022. He did a lot of extra neat things to get even more support into the match statement. I'm not going to cover those. because this is already complex enough. So what do you do if you want to use it? Well, of course, you need Python 3.10 for this. If you're stuck with Python 3.9, then the only way is to basically to avoid the syntax errors that you would get if you put the code into your modules, is that you basically have two implementations of everything. One using match statements and the other one using the classic like if, elif kind of construct. And then you do a try import, and then you can have both ways. And then once you move on to 3.10 or probably even better 3.11, which is much faster, then you can just drop the if statement kind of version of everything. So I'm going to go through 3 different topics here, explaining some of the details. First JSON, then XML, and then AST parsing. So let's start with a simple one, JSON and tabular data. So basically this could be a spreadsheet, like a standard table that you put into JSON, and then you want to parse this. There are a number of things that you have to consider here. One is that in JSON, for example, you have numbers which are either integers or floats. And of course, if you want to match these things in Python, you have to match both integers and floats if you want to capture all those numbers. And of course, you have other things like strings, which are easy to match. If you want to do things like the properties up there, where things are nested, then you have to use different logic. You have to nest your match statements. And I'm going to get into that a bit later. So if you want to match a JSON record like that one with the schema that I put on the right, it's actually quite easy. First, what you do is you match the instance. You check whether it's a dictionary. If it is a dictionary, then you open a second match. And this is kind of like a theme that I want to advertise. Don't make your match statements too complex. Keep them simple and use multiple ones. And if the code that you have here becomes too long, then use different methods to match certain parts of your structure, or use different functions for these things. So what happens here is you match on the name. You say, okay, it has to be a string, and you want to capture the value in the variable name. The second is the price. Price can be an integer with price or a float with price. And what you see here is something new. This would be an explicit capture, and this is an implicit one. So what you do in the second case with the price being inside the brackets of int and float, you basically tell match that it should be an integer, and you want to capture the variable for that integer in price, or the same for float. This can be a very nice way to do things. I would not necessarily recommend always using these things because there are certain implications. It's also not supported by all the built-ins, but quite a number of built-ins. You have to look in the PEPs for the exact list. But it is a way to write things quite nicely and quite short. Again, you have the extra here, so you capture any extra variables that are defined that shouldn't be defined according to the schema, and then you can do error processing here. And once you've matched everything, you can go here and process your data as usual. So what you see here are typical patterns. You match things. You put the matched data into variables, so you can do both the parsing and the actual processing in a single step, which is nice. And you can also do easy error processing, right? If you find things that shouldn't be there, or you find that certain types don't match, you can do error processing directly in here. If you want to match multiple of these records, then of course you should open up a new function, or you basically put the code into a different area of your application, and then say, okay, I have many instances, and those many instances should be a list. And then you go through that list and you parse each of those entries using the function for parsing a single entry. Now, a second example, GeoJSON. How many of you know what GeoJSON is? A few. So it's basically a way to define geodata. In this case, it's a small island here in the Philippines, and it gives you the coordinates and the name of those islands. and you want to match that. There's a standard for this. You can look that up on geojson.org. And if you want to match a structure like that, then I've put the example data there on the right. What you first have to do is you match the instance. You have to check whether there's a type definition. And if there's not, then basically you would say, OK, I can't match this. Then once you know that there's a type, you have to check whether it's one of the valid types. And you cannot do that directly in the match statement. You have to then use an if statement for that, and you define the valid types. And again, you can do the error handling directly in here. And then for the other members that you have in here, you match all the different members that you are looking for, and then you store everything in your data, or you start processing the data. So this is very easy. XML is kind of similar. Now, for XML, you wouldn't directly go in and parse the XML using match statements, of course, but what you do is you take a tool like Elementary, for example, to parse everything, to convert everything into Python structures, and in this case, objects, and then you try to parse the data out of there. So what you see here, this is actually an example taken directly from the Elementary documentation. It has certain country data, and you want to match that country data and extract it from the data set that you get. And how this works is very similar, except that in this case you're using instance patterns for this. So you see here the Elementary element, and then you parse a tag called country. You get the attributes out of those elements, and you take the data and then continue processing everything according to the schema that you have for these things, and you extract everything. And then, because this will always give you string data, you then can convert everything into data types that you can actually process. For example, the rank you can convert to an integer. The year as well. For the GDPC, you're going to use the float. And then you can store extra data, for example, the neighbors. Neighbors can be an arbitrary list of neighboring countries. And you put those into a new data structure that you create over here with a dictionary, and you put all the data that you find in there. And then finally, you store everything here in a country's dictionary, and you can then process the data. So this is a very, very clean way, a very easy way to write a parser for this data. If you do that using if, elif, it's going to look very unpleasant to read. It's not going to be, it's very easy to introduce bugs in these things. So I would always recommend doing that using the match statement. Right. Now we're going to come to the next example, and this is the final example. It's also the most complex one, is parsing an AST. How many of you know what an AST is? Okay, about half maybe. So it's AST stands for Abstract Syntax Tree. So what happens is that if you have a compiler, and the compiler wants to basically take the input program that you have, like the text that you see here on the left, and convert that into some kind of code. In Python, that would be code for the virtual machine. If you have a C compiler, it would be machine language. Then you convert everything that you see here, all the text, first into tokens. Tokens would be like, for example, the def or the if or the and, or like in a for statement, the for. Those would be tokens. And then you collect all these tokens and put them into a tree structure. And what I've shown here on the right, this is actually the output of the Python AST. And as you can see, it's a very deeply nested structure, very, very detailed. All the details that the compiler finds are put into these structures. And then the next step would be to then take that structure and convert it into bytecode. So what I wanted to do as an example here is I wanted to convert this way of writing things, which is the classic if, elif, else kind of approach to parsing, convert that automatically into code that uses the match statement. So, are you still following me? Yeah? Good. So I'm going to have a few slides showing all the different functions I used for that. The first one is this one here, the function that basically gets the function as an object and then uses the inspect module to get the source code for the object. Then you convert the source code to an AST using the AST module. You get a tree, and then you step through the tree, and because you want to not process everything, but you just want to process functions in there, functions that look like this, right? So I have to be a bit more specific to basically keep the example a bit shorter so that it actually fits on a few slides. What I do here is I take functions, and then the functions, they should have a variable, and the variable is basically the variable I want to match on, right? So if I have a function, and this is what I'm doing here, if I have a function that uses a particular name and then has a single variable here as a matching variable, I want to extract that information and then do refactoring on that. So in the code here, what I'm doing is I'm basically searching for functions that have a name, and I'm capturing the variable name of that single variable in here. If I put in a function with more than one variable, this wouldn't match anymore. And then what I do is I basically branch out to a new function refactor, which is there on the right, to actually do the refactoring of that particular function. Now, what happens in here is, again, I go through that function code, and I try to find all the if-elif kind of statements in there. So the way that that works is that I go into the function body, and then I try to find if statements. And the way if statements work in ASTs is that they have three components. You have a test that you try to check, and then if the test, if the condition matches, then you go into the body part. If it doesn't match, you go into the or else part. So if you write let me go back here. Oops, sorry. If you go back here, the if-elif kind of thing is looks very linear, but in the AST it's actually a deeply nested tree. So it goes down very deep into the structure. So what you do here is when you find something like this, then you start scanning that if, and you check whether you can actually match this. And then if you find something that you can refactor, I put these into the cases here, then you call another function to actually do the refactoring. And once you've done the refactoring, everything is very easy. You just take the node that you get from the refactorer and you replace it with the if statement that you found. You replace the if statement with the new match node that you created for that. So what do you do if you want to scan the if and check whether it actually matches? Again, you go into the AST. There are two cases that I want to consider here. One is without a condition, and a second one is down here with a condition. Right? So over here, I'm matching the call is instance and then variable name type name, and down here, I'm basically doing the same thing plus an extra condition that I have down here. So what I have to do for this is, again, I have to look how the AST looks like for these kinds of calls. And I'm doing the first part in here, which is quite simple, and the second part has an extra Boolean expression down here, and you can see that in here in this case statement. Again, it looks a bit complex, but if you look at the details, you're not really doing a lot. You're basically just trying to find the is instance in here. Then you're using the variable name that you had in your function definition. You check that, and then you capture the type name that you want to check in this type name variable that you have there. Now, if something matches in these two cases that you have here, then you take the cases and you collect them in a list called cases. If you have an unsupported if variable, if variant, then you just basically return everything as it is. You don't refactor. And now once you have everything in here, you also have to check whether the list actually goes down further and whether you have additional elifs in your list of branches that you have in your if statement. And you do the same thing over here. You match the if you check everything, you use the scanif recursively on these things, and again, you collect everything in cases. And now that we know what we can refactor, we do the actual refactoring. And that's very easy, because we just use the different cases that we have, and we create a new match node for these things, and put the data that we've collected into those match nodes. So once you've done that, you can actually run this code on the left side, and you automatically get the right side. Right. So those were the examples. Now some benchmarks. Of course, I'm always into performance, so I wanted to see how it performs. I compared the match variant with the corresponding if variable using is instance. And what you see here is basically a collection of benchmarks. All of these values are nanoseconds, so it's not really, it doesn't take a lot of time, but you can see that the match variant often is quite a bit slower than the if variant, right? So in most cases, it takes twice as much time, except for one case, which is the list of integers, where it's actually a lot faster. And so it's interesting to be able to do these things and actually get faster code. There's also a very weird thing that I noticed, which is in here when you use capturing variables. I mentioned the two different ways of writing them, using as and the inline ones. And I created test cases for both. And I found that using the inline version is a whole lot slower than the generic one, even though they basically do the same thing. It's just a different way of writing stuff, right? And just as a reminder of how you write these things, I think this is actually a bug in the implementation. Not a bug in the sense that it does the wrong thing, but a bug in the sense that the performance isn't right. So conclusion for benchmarking is match is about 2 times slower than the if statement. And it's really nice for doing simple things like matching a list of integers, for example, or list of values in general. That said, this is not necessarily negative, because what we're still using in Python, even 3.13, is the first implementation of this. So after the PR got merged into 3.10, nothing much happened anymore. So there's still a lot of possibility there to improve things, to optimize things and make things faster. So it's definitely not a reason to not use these things. And the overall conclusion here is that match makes it a lot easier to write parsers, and it's also incredibly useful if you want to write readable code, right? If you compare this nonsense here with this kind of piece of code, it just looks a lot nicer. It's a lot easier to understand. And it's also not as error-prone as the left part. So I would always recommend doing these things, and always recommend learning new stuff as it comes along. Right, these are the resources. I already posted that before the talk. For the benchmarking, I wrote a new package called the micro benchmark package there. This makes it a lot easier to write micro benchmarks and run them. If you're interested in these things, then go have a look. It's still an alpha. It's still very much in development. But it's quite useful, and it makes writing micro benchmarks a lot easier. And you can, of course, then download everything, the tests that I did from the GitHub, and also run them on your machines. Maybe you get different results. Right, thank you.
Thank you very much for this very interesting presentation. So we have time for maybe 1 or 2 questions. Rodrigo asks, what you called an instance pattern doesn't really build the instance to do the matching, right? It looks like an instance, but it isn't one.
Yes, exactly. It basically it checks the type, and it checks the attributes that you put into that pattern. That's it. It doesn't actually build the instance.
And the other question is, do you know why was it decided to not support case fall through, like in switch case without a break? This seems to limit flexibility and promote code duplication.
You mean like what you have in C, when you forget the break, that it basically goes to the next one. This is a constant source of bugs, right? And it's, because of course, the C Python interpreter uses the switch statement internally, and we've had these issues, right? So we decided, well, it's not a good idea, so let's not do it.
Okay, that's it. Thank you very much.
Thank you.